management and disaster and risk reduction. I'm greatly honored to introduce you our distinguished speaker, Dr. Ravindra Kale, a highly respected scientist in the Surface Water Hydrology Division at the National Institute of Hydrology, Roorkee. Dr. Kale's expertise span a wide range of the hydrological field, including flood modeling, hydrological modeling, water-related disaster reduction, climate change impact assessment, and integrated water resource management. His contribution to the sprinkler and drip irrigation system, pipe flow hydraulic, and the drainage system design have been invaluable in advancing the water resource management in India. He holds B.Tech degree in agriculture engineering from Mahatma Phule Krishi Vidyapeeth, Maharashtra, and M.Tech degree in agriculture engineering from the G.B. Pant University, Uttarakhand. Sir earned his PhD in hydrological modeling from IIT Roorkee. Further, his solidifying expertise is in water resources. Dr. Kale has also enhanced his knowledge globally through the Knowledge Co-Creation Program in the Disaster Management Policy in Japan and as a visiting scientist at International Institute of System Analysis, Austria. His outstanding research has been widely recognized, including receiving the Best Research Paper Award in the year 2013 and awarded the Best MTech Dissertation at the IIT Roorkee. Additionally, he was also honored with the Outstanding Presentation Award at GRIPS Japan. Dr. Kale actively contributes to international research as a member of the Flood Risk Management Committee of IAHR and Indian Road Congress subgroup on the hydraulic of bridges. Sir has published 19 research paper in reputed journal and conference, 15 book chapter, 25 technical report. Dr. Kale's contribution continue to shape the water resource management and hydrology research. We are privileged to have Dr. Ravindra Kale with us today and look forward to Sir's valuable insight. So I'll stop sharing my slide. Over to you, sir.
Kale sir, can you hear us? Sheetal ma'am, I just called sir.
Participants, if you have not filled the feedback link, please fill it. It is available in the chat box.
Dear participant, I have shared a feedback link in WhatsApp group as well. So you can access that. Yes. Ravi sir, you can present now.
Okay, thank you very much, madam.
Yes, sir.
Good evening, all. Just I'm saying my presentation. Just 1 minute. My presentation is visible.
Yes, sir, your presentation is visible.
Okay, okay. Okay, good evening, all. I'm going to present my lecture on flood disaster risk reduction under changing climate. Madam, I'm audible. Hello.
Yes, sir. You are perfectly audible.
And presentation is also visible.
Yes, sir. You can carry on, sir.
Okay, thank you, madam. I'm going to present my lecture on flood disaster risk reduction under changing climate. Here, one thing I want to tell you, generally we talk about flood disaster risk management, but there is a one world global body. Previously, there was a concept of disaster risk management, flood disaster risk management. But yeah, if you we look at disaster profile at last 20 years, then you can understand that disasters are generally on rise because intensity, number of weather event are increasing. So people becoming more and more vulnerable. That's why death toll, economical losses are on rise. So now concept has been changed because previously, we called it as a flood disaster risk management, but now people globally are trying to reduce this disaster risk. So basically, I want to talk on flood disaster risk reduction under changing climate. So I will show some case study here. So background for this study is, as we know, India is the worst flood affected country in the world after Bangladesh, which account for 1/5 of global death count due to floods. This is based on Dartmouth Flood Observatory database. And if we see this economical losses chart since 1998, then we can clearly see that in recent year, last 10 years, these disasters, number of disasters are increasing, and also losses are also increasing. And one another thing, because most of our losses are not insured, that uninsured losses are increasing in India. Basically, in this case, we can see that year of 2014 and 2019, there is a lot of losses. One of them in 2014, one of big event is Jammu and Kashmir flood. So in this lecture, we will see the simulation of that flood disaster in Jammu Kashmir, basically of Tavi River Basin. Then another biggest year is 2019. In that case, in Maharashtra also, Sangli and Kolhapur region seen very big floods and many cyclonic. So basically, in this lecture, we will see disaster in Himalaya and some coastal flood disasters and how to estimate this flood risk by using different engineering techniques. Basically, if when we see the India's vulnerability to disaster, we can see that India's share of death worldwide in natural disaster is around 32.6%. India's share of people affected is around 72%. That is in 2013, but it is now increasing. Then India's share of economic losses is about 2%. India's share of people killed in 1993 to 2012 around 57%. India's share of people affected in 1993 to 2012 is around 19.1%. So basically, here we see that the flood disaster is most important disaster which causing a lot of losses in India. And this chart also showing that number of vulnerable people are increasing, even though our technical capabilities are increasing. Then also due to because a lot of population living in vulnerable area, that's why number of people affected due to this disaster impact is increasing day by day, and also economical losses are also on rise. This is by UNDRR. This is report of United Nations Disaster Risk Reduction Committee report is this. So when we see natural disaster event in India from 1995 to 2015, here we clearly see that number of occurrences occurred in case of floods are more as compared to other disasters. Then total death occurred in India due to flood are more as compared to other disasters, and total damages also due to this flood is on rise. So basically, here we can see that uh, frequency of flood disaster is increasing. Now it is around 8.2% frequency times per year flood event occurring in recent year as compared to other disasters. That average number of death per person per year also on rise in case of floods, and average economical losses or economical damages also on rise as compared to other type of disasters. That's why studying this flood disaster is very important. And one of the report of Government of India, according to that report that presented in Rajya Sabha in 2018, India lost 1,808 lives and suffered losses worth an estimated rupees 957 billion. That means 95,000 crores rupees we lost on average in 1 year due to these flood disasters from 1953 to 2011. And on an average each year we generally lost around 36 100 crores rupees every year due to these flood disasters. So here we see what are the flood prone area in India and damages in year 2020. So here I have given number of floods and their economical losses in terms of US dollars. So one of the big flood event we can recall that occurred in Kedarnath during 2013, and around 4,000 people lost. But this is a government number. But it is said that a lot of people uh, 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 has been lost their lives during this Kedarnath event. Then there is another event of Jammu Kashmir that occurred in September 2014. During that event, 300 people have lost, and around 27 million US dollars rupees we have lost during that event. In case of Mumbai flood that occurred in July 26, 2005, around 1,100 people lost their lives, and economical losses was around 690 million US dollars. So there are number of like here in Krishna River that flood occurred in 2009, 2019. Actually, it is 2019 flood. So all we can from this slide we can see that number of event on rise, and also by year economical losses on rise generally. And this graph is also showing number of death in state-wise death due to the flood disasters in 2020. In that chart, West Bengal is leading this list, and here we can see that Maharashtra also number of people lost their life due to this flood disaster is also around 50 people in Maharashtra lost their life due to this flood disaster. And according to one report, in 2020, extreme monsoon rains in India caused floods and landslides. Between June to October, extreme event caused at least 2,000 deaths and damages amounting to rupees 73,000 crores. This is very big amount. So that's why we need to study these flood disaster in details. But one thing in case of floods is flood doesn't occur alone. There is combined event of flood and landslide. So floods and landslide are the most frequently occurring natural hazards, particularly during the monsoon season. And this case is applicable to Himalayan region, also in Western Ghat region in southern India. So here we will see what are the different type of flooding. In case of flooding, there is four type of flooding: fluvial flooding, cyclonic flooding, and tidal flooding. Fluvial means that flooding occurred due to the only due to the rainfall, and fluvial is the flooding in the in the rivers, and that is connected with the management of reservoirs and channel carrying capacity of river channels. So that we call fluvial floods. Then there is another kind of cyclonic, because we have number of cyclone landslide in east coast of India. So due to that cyclonic conditions, there is huge flooding delta regions occurs, and that we call as cyclonic floods. In that case, we require to consider fluvial floods and also coastal floods due to rise of ocean. And then another kind of flood is tidal floods. In this case, rise of heavy tides in ocean, the coastal area get inundated. So generally there are these four type of flooding. So basic question is, what is flash flood? Flooding that begin within 6 hours and often within 3 hours of the heavy rainfall or other cause is called as flash floods. That means in that case of floods, when there is a rainfall start in our watershed area, within 6 hours, flood peak reaching to catchment outlet, then that flooding is called as flash floods. In what happens in case of flash flood is, we get very less time for preparedness, because in case of conducting different mitigation measure, like we have to evacuate people from some location, then we require some time. But in case of flash flood, we get very minimum time, because flood peak reaching that location within 6 hours. So that's why it is very important type of floods. Flash flood can be caused most often due to extremely heavy rainfall from thunderstorm, dam or levee breaks, bricks, or mudslides. We call it as a debris flow. The intensity of the rainfall, the location, distribution of rainfall, the land use, topography, vegetation type, and growth intensity, soil type, and soil water content all determine just how quickly the flash flooding may occur and influence where it may occur. Urban areas are prone to flooding in short time span, but flash flooding occurs so quickly that people are caught off guard. So that are the main characteristic of this flash floods. So what are different flood management approach? Based on the flood type, we have to set our different flood management approach, because first we require stream flow forecasting. Then we have reservoir operation. Then we have to analyze extreme event. Generally, we can predict or forecast extreme event, that is a rainfall event. Then floodplain inundation we compute. Then we generate vulnerability map, and then finally we go for climate modeling, and then assess the impact of climate change on these extreme events and flooded area. So this is general approach we use in flood management. Then what is the impact of flood we will see in the slides. So I am taking the case of Tavi River. So we will see how to set hydraulic modeling. We call this HEC-RAS. HEC-RAS is hydrological engineering corps, that is US Engineer Institute, and they have developed HEC-RAS. RAS is River Analysis System. And here I will tell how to this set this Hecras model. Basically, this Hecras model is based on set penalty equation. That is a mathematical models, and it solve hydrodynamic problems. So this is we are seeing this map of Tavi River, and Tavi River is characterized by flash flood conditions. So some information about the study area is the major left bank tributary of Chenab. This Tavi River is major left bank tributary of the Chenab River. It origin in lap of Kailash Kund Glacier and adjoining area southwest of Bhadarwah. Then this is the lat long of this watershed. Here also you can see the lat long of this watershed, and elevation range of this watershed is varying between 239 to 4,300 uh, uh, 31 meter. That means the topographical variation in this watershed is very high, because it is elevation is the this at this point is around 4,300 meter, and at this outlet is around 239 meter. That's why there is a lot of steep river gradient is occurring. That's why even the total catchment area of this basin is around 2,600 kilometers square, but flood comes within 7 hours at the outlet. And this the climatic condition of this river basin is subtropical monsoonal climate regime, and annual rainfall occurring in this watershed is around 900 to 1900 millimeter. And geologically, this area is Himalayan area, Western Himalayan area, that is formed by metamorphic terrain in the higher reaches and sedimentary rocks in the lower reaches. And it is a mesogeomorphic geomorphic region. And north of the Panjal thrust, elevation around 1900 to 4,000. This point to this point, this is called as Panjal thrust, and Panjal thrust to the Udhampur thrust. Between these two color we call is Panjal thrust, and elevation vary between 700 to 1900 meter above mean sea level, and low hill lock between Udhampur to from this point to this outlet point. It is low lying area and elevation less than 700 meter mean above sea level. So basically, we have conducted a study to riverfront development in this reach near to Jammu. So this is the uh, uh, DM digital elevation model of Tavi Basin. It is a 3D view. You can see, and this is Alos Dam. 30-meter dam is there, and that downloaded from JAXA. And here you can see that the different elevation at different point, and origin and outlet of these rivers. And at this lower laying area, the Jammu city is situated. And in this point, Katra, that is Vaishnav Mata Devi temple is here. So these are the some damage picture that occurred during 2000 floods, and you can see here there is one under construction barrage was there, and during construction only due to these heavy floods that barrage get damaged, and this bridge also get damaged. So we have analyzed what factor caused to damage this infrastructure, and how to design riverfront in this case. So we will see. So these are the some pictures and some overtopping of that bridge. You can see here how this bridge is overtopped. My PPT is visible. Hello. Hello.
Yes, it is visible.
Yes, sir, it is visible.
Here we can see that how this bridge is overtopped. This bridge is overtopped in 2021, and we have taken this video. So these are the rescue helicopter of army, because almost every year, people due to this flashy nature of this river, people get trapped inside this river ridge, and that's why almost every year we have to conduct some rescue operation there. You can see some pictures. So how to conduct this hydrodynamic study to study these flood situations? So under climate change, so this is the workflow to conduct this study, to manage the flow of information for flood inundation mapping. So basically, we require some climate change modeling. Then we have hydrologic modeling tools, and flood mapping. And then we have to suggest some flood mitigation measure. So for that purpose, we require some initial field visits, some data collections, and for this study, we require some data like data from Earth observation monitoring, satellite data we can use, then some observed data we required. Then we require numerical weather prediction model outputs, data modeling integration with hydrologic and hydraulic models. Then we have to assess these modeling results, and then we have to provide some input for decision support system. Here I want to clear one thing to you. What is the difference between hydrologic models and hydraulic models? So hydrological models, basically this is rainfall and runoff component, because we know that there are different factors that affect flow of river from the catchments. Because when there is a rainfall, there are a number of parameters like soil parameter, land cover parameters, then our infrastructure. Because for that purpose, hydrologically we decide different parameters, and we generate runoff based on the rainfall. It is some kind of conceptual models, and based on the hydrological principles, we call it as a hydrological models. And hydraulic modeling tools that are based basically on the mathematical equation. We called it as a Saint Venant equations, and it is based on fluid dynamics. So this is the basic difference between hydrological model and hydraulic models. Hydrological model basically based on hydrological principle, and hydraulic model based on fluid dynamic principles. And we take integrate input of hydrological model into hydraulic modeling tools, and they based on this in output of these two modeling tools, we generate flood maps, and based on these flood maps, we suggest flood mitigation measures. So in case of the flood modeling studies, because we have tools, different mapping approaches also there, but based on our needs, we require to select time step and spatial scale during this hydrological or hydraulic modeling. Suppose we have to go for flood early warning system, then we require extreme weather forecast, that is nowcast we called, or hindcast data we use for flood warning. Then if we require some scenario based assessment for development purpose, in that case we can use stream flow and other data. And in case of some synaptic view, we want to view these disasters, then we can use satellite based discharge or other data. So these are the timeline of flood and various modeling approaches for disaster risk reduction in case of floods. So what are the input data required for this modeling purpose? Generally, we require DEM. DEM is digital elevation model data. DEM resolution range between 1000 meter to less than 2 meters. 2 meter resolution is preferred for flood inundation mapping, but it is very costly. And in case of India, we generally get Cartosat dam, that is a 10-meter dam, and other freely available global dam are having special resolution around 30 meter. But one thing is here, we have to use DTM, not DSM. There is difference between DTM and DSM. DTM is digital terrain model and DSM is digital surface models. In case of DSM, it take into account the height of different structure like building structures or trees. So that elevation in case of DSM is sometimes erroneous, but in case of DTM, that man-made structures or trees, natural trees that get removed in DTM. That's why in case of flood modeling, we generally prefer DTM, digital terrain model, and it required for determination of topography for hydrologic and hydraulic modeling and flood mapping. Then we require aerial and satellite images. Basically, these aerial and satellite images we require to calibrate and validate our models. Because in case of flood mapping, we doesn't have observed data in many cases. Like we have to generate flood inundation map for any particular city. In that case, we doesn't have observed data at that place. In that case, we can use aerial or satellite images to calibrate and validate our models. That purpose we required aerial and satellite images. That there is a lot of satellite images are available nowadays. We can use Landsat images, then MODIS, then Sentinel data is freely available. Then there is some kind of commercial data is available like LIS3, LIS4, that is provided by ISRO India, NRC, and some global data is also commercially available for this flood mapping. But only thing about this commercial product that data is very costly. Then for flood inundation modeling, we required LULC, that is land use land cover maps. That input data we generally required for hydrological modeling. Then we required soil map for hydrological modeling, geological data for hydrological modeling, historical characteristic and flood marks. That data input data we required for hydraulic modeling and flood mapping. Then meteorological data and radar data including meteorological station characteristic. That data we required for hydrological, climate change and hydraulic modeling. Then we require climate change scenarios for hydrologic and climate change assessment. Then river stage discharge data. If we are going for flashy river, then we require hourly or sub-hourly data. Or for big basin, we can manage with daily data of river stage and discharge data of river gauging sites. That data is important for calibration and validation of hydrologic and hydraulic modeling studies. Then we require data of hydrological structures like data of bridge, culverts, dams, confluence of rivers, waterfalls, other necessary structures. That data we very detailed data required for hydraulic modeling. Then roads, buildings, settlements, functional zones, and point of interest. That data we required for generation of flood hazard maps and flood mitigation generation of flood mitigation maps. So input data status. In case of DTM, we can use 30-meter grid dam data. That different source data are SRTM data, that is by USGS, Aster data, ALOS world data, this is by data by JAXA, Japan. Then Carto dam data is given by ISRO. Then ALOS RTC data given by ESA, that is European Space Agency. Then we can get 2-meter data also, but that data we have to purchase. In this case, this data is purchased from ALOS dam, that is by JAXA, Japan. Then we required very high resolution precipitation data. Generally in India, we get grid data at 0.25 degree daily data, but for flash flood in modeling, we required hourly or sub-hourly data. Then we require soil type data, and that data we can get from NBSS LUP, that is from Nagpur, that is National Bureau of Soil Survey and Land Use Planning, or we can use FAO, that is United Nations Organization. That data, soil data, we can use in our modeling studies. Then we require land use data. That data we can get Survey of India, or we can use derived LULC product from Landsat or Sentinel images. Then discharge data, we require hourly or daily measured discharge and stage data. And also we required cross-section data. In this case, we received this data from Jammu Kashmir government, WA department, Jammu. And these are the GIS data prepared for hydrological modeling. In this case, we prepared meteorological station data, then sub-basin map, land use land cover map, gauging station map, stream order maps, and soil type and texture maps. And these are the different data we are generated for this study. Then we have divided this basin into 9 sub-basins. These are these sub-water sets like Balini, Balol, Chirwa, Dudar, Gambhir, Jajjar, Ramnagar, Sadhana, and Sohagani. These data, and these are the catchment area of these different sub-basins, and these are the stream orders of these basins. Then we have generated this purchased this LULC map from Survey of India, and also we have generated this map using Landsat images, and we have found out the percentage of area by different land use. Like here for agriculture, according to Landsat images, agriculture area is around 1063 square kilometer. Likewise, we have generated this share of different land uses in this catchment. Then these are the different soil texture classes. This data we required for this river basin. So after preparation of these different maps, we required to collect high flood events in this basin. For this study purpose, we have collected data from high flood event data from 1977 to 2019. And in this case, we found that the flood event in 2014 is biggest, and you can see that even watershed area of this basin is around only less than 3000 kilometers square, but this discharge value is very high. Even in Krishna river is also, we cannot observe that kind of discharge, and this is a particular characteristic of this flashy Himalayan rivers. So modeling task is also challenging in this case, and this is the period that flood event occurred during 2 to 9 September 2014. So we are going to analyze these events, and we compared this event with World Catalog of Maximum Observed Floods, that is international body IHS, International Association of Hydrological Society. And here we can see that this is the one of the biggest event we can find. This is perfectly matching with these world records. And there is another world maximum observed floods that by World Meteorological Organization, and in that case also here is we can see that the flood event of 2014 is biggest flood events based on this catchment area of this basin. For this hydrological study of this Tavi basin, as per IMD data, the highest ever recorded rainfall during 24 hours in Jammu district is 270.4 millimeter in year 1998. But during year 2014, very heavy rainfall event from 3 to 6 September 2014 was occurred for almost the entire JK state, which was perhaps unique and unprecedented rainfall event. And there is one study by IMD done by Ray et al. In 2015, and they attempted to analyze this catastrophic event over Jammu and Kashmir. The important result from these analysis were the AWS. AWS is the automatic weather station that's situated in Kawa, Udhampur, near to Katra region, which received the rainfall of 260 millimeter on 6 September 2014, whereas Jammu station has received 218.3 millimeter rainfall during only during 24 hours. The highest hourly rainfall of 35 millimeter was recorded at AWS Kawa, Udhampur station on 6 September 2014 between 2 and 3 hours IST. That means this event occurred at night time, and it is very difficult to analyze conduct the response activity. Then there is another thing is that the 3-hour heaviest rainfall recorded at AWS Kawa station Udhampur between 0 to 3 hours was 101 millimeter on 6 September 2014. The rain were continuous and consistent from 4 to 6 September 2014 with an average rain rate of 10 to 12 millimeter at Kawa. From this study, it was concluded that during year 2014, the rainfall exceeded 200 millimeter per day limit set for severe storm. That means it is very biggest event that occurred over Jammu and Kashmir. In Tavi River catchment, about 210 kilometer square area is above the snow line. Thus, the net rainfall area up to Jammu is about 964 kilometer. Therefore, selected 24-hour storm of 21 and 19 centimeter for 100-year and 50-year return period respectively appear to be reasonable. That means within 2000 kilometer square area that runoff is get generated. So it was a very big event that occurred over Jammu and Kashmir, specifically on Tavi River basin. And in hydrology, when we doesn't have any observation data, generally we use unit hydrograph technique, and we attempted to generate this synthetic unit hydrograph for this Tavi basin. And this synthetic unit hydrograph method is recommended by Central Water Commission, that is a apex body in India for measuring and management of flood. And according this flood estimation report for Western Himalaya Zone 7 has been used to estimate design flood hydrograph for 50 and 100-year return period. Generally, when we want to design any drainage system in any city, then generally we took 50-year return floods. And when we have to design very big structure like dam, then we use 100-year return year floods. And for this basin, by this method we found that the peak time to reach the highest flood at the outlet was around 8 hours from uppermost point to outlet point. Only 8 hours is required to reach peak of the floods by using these unit hydrograph techniques. And here we can see that this this hydrograph perfectly matching with observed data. We can see this next time, next slides. Then another approach is hydraulic modeling approach. Then how to use this data in our hydraulic modeling tools? I already told about HECRAS modeling tools. In that case, we have two approaches. One is steady state and unsteady state. Generally, in nature, steady state flow doesn't occur, because what steady state flow suggests that there is along the space, flow velocity and water depth remains constant. But in nature, such kind of flood doesn't exist. But for engineering purpose, generally we use this method previously, because computational cost of this steady state simulation is very low as compared to unsteady state. But unsteady state simulation has many advantages, even though it required a lot of computational power, but results are very accurate. And in that case, we can take into account different hydraulic structures like bridges or different weirs. We can take into account. So in that case, we try to use these unsteady state flow simulation models in our study. So this is the hydraulic reach. This is a point just upstream of Jammu, and this is a Jammu region. You can see buildings of Jammu city, and we have developed this model. And this information about how to generate these geometric files, these different river cross sections. Then there is left and right bank. Then there is central line of river. We called it as a geometry files. The geometry files with cross section, bridge and barrages information has been used to generate these geometric files. In case of Tavi, it is mostly assumed that 65% and 35% flow by bifurcation in the Niki Tavi and Wadi Tavi, because in case of Tavi, near Jammu city, this river get divided into two channels, one called as Niki Tavi and another branch is called Wadi Tavi. Niki Tavi is a small river and Wadi Tavi is big rivers. So previously there was around 65% flow was flowing in Wadi Tavi and 35% uh, uh, flowing in Niki Tavi. But over a period of time, due to sedimentation or deposition of sedimentation, flow condition get reversed. Presently, around 72% flowing into Niki Tavi and 28% flow is flowing in Wadi Tavi. And one important aspect of this place is when there is a between distribution and confluence of these two branches, the our army place is situated in between. So this is very important area, and we have tried to model this flow situation hydraulically using these Hecras models. In the present study, the splitting of flow Niki Tavi and Wadi Tavi is modeled using energy balance method, and it is hydrodynamic approach option available in Hecras model. So these are the results. So these are the bridges in this reach, and we doesn't have observed data. So in between these, we have observed data in between these two bridge, and we try to see whether our this value calibration value matching with this region, and based on that, we require Manning roughness coefficient to be used in this Hecras modeling. And based on this calibration and validation, we have selected 0.02 to Manning roughness coefficient for this river reach. And here you can see the actual fluid situation. And using these photographs, we have used these scenes to calibrate and validate our hydraulic model accurately. And in previous image, you can see that similar case we are able to simulate in our hydraulic models. So this is the actual channel system we have generated in our Hecras models, and different bridge also you can see here. And similarly, whatever you are seeing in last actual video, here also you can see how flood and at what time this flood is occurring. And by seeing these are the actual bridge we have seen in our one of the photograph. This these columns get damaged, and here also in our modeling study, here we can see that the water is overtopping that area due to faulty designs, so that area get damaged. and we can analyze where our design is got faulty. So here you can see that the water line is overtopping these columns of under construction bridge. So, and this is in front of this there is a bridge. So by using this modeling, we can analyze in details uh, what parameter we have to fix during design, and if there is some failure of structures, we can analyze how we can remove this fault in our actual modeling. So this is the case. So based on this hydrodynamic model, we have estimated that flow bifurcation ratio for different design flood condition ranges between 70% to 73% and 29% of the total flood at the junction for Nikitavi and Vaditavi respectively. And for this hydrological modeling, another problem, because we have generally daily observed rainfall data, but as we previously seen that the concentration time for this basin is only 8 hours. That means we cannot use daily data. Then we have to disaggregate our daily data into hourly data. And luckily, we have two gauging site, two hourly gauge situated at Udhampur and Jammu. And this hourly rain gauge we have used to disaggregate these models. And yeah, in this case, we have used bivariate satellite ratio disaggregation methods. And then we, for different lines sub-basin, we have generated this hourly hydrographs. And here you can see this generated hourly hydrograph from daily measured rain hydrograph. And this is we then developed HMS models, and we have calibrated these models and validated these models. This is for Jammu's gauging site. This is for Udam gauging site, and here we can see that uh, very satisfactory result we have got during calibration of these HMS models, because we require to use this output of HMS models into HECRAS model for river analysis. And these are the validation results for these Tavi basins. And during the validation also, we have got very good results. Then another thing is setting up HECRAS model for this flood inundation mapping. So from this point to outlet of this point, we have divided this channel into 4 sub-reaches, like this is Upper Tavi, Vadi Tavi, Niki Tavi, and Lower Tavi. And we have set up HECRAS model for these reaches. And these are the inundation map. And that from Landsat 8 images we have estimated, and also we have some observation. Like there is one agriculture college in Jammu city, and from seeing the height of this vehicle, we have estimated how much flood inundation depth was there, and we have checked from our analysis also whether we are able to achieve this height or not. So because already I have told that we doesn't have observed data for this flood inundation condition, then we have from different photographs we can analyze, because we have GPS. From GPS we can take elevation of any particular point. So by using GPS and seeing this picture, here you can see that half of the tire of this vehicle is get inundated in these floods. And from this we have estimated how much inundation depth was there, and actually we have to try to simulate this depth in our actual hydraulic models. And based on that we have calibrated and validated our models. Then another part is how to use this climate change scenarios, because presently we have different climate change models data. So basically we have used these different regional climate models and like next GDP and Codex South Asia data. Basically, we have used CMIP 5 data. In that case, there is RCP 4.5 and RCP 8.5. We have used this data. And then because in case of practical purpose, basic thing is because there is a lot of uncertainty exists in this climate data. Then how to use this climate data for practical purpose? That was biggest question before us. So we have conducted different estimated different parameter, and in that case we have found that this R20 parameter is very important, and that we can use in our study. So based on these different scenarios, we have choose best scenario for our study area. Then we found out this R20. R20 factors means rainfall exceeding 20 millimeter at any location. So based on that, we generated these parameters, and in addition to the continuous wet conditions, this is CWD, another factor we have studied, that is the number of very heavy precipitation days. R20 is the important determinant for the flood occurrence. That two parameter we have found most important to study the climate change impact on the flood inundation in this basin. So we have, based on this our actual observed map, we also generated 100-year flood inundation map and also flood hazard map for this Tavi basis. And this is flood hazard map, and this flood hazard map also showing color code. This color code is important because this blue color is between flood inundation depth is between 0 to 0.3, because in 30 centimeter flood inundation depth, any human being can walk, but beyond that it is not able to walk. Based on that condition, there is some standard color code is there to generate a flood hazard map. By using this different color codes, we have generated this hazard map for this Taveri region. And we also included some important places and some infrastructure during generation of this hazard map for Tavi. And this is flood hazard map for 100-year return period floods. And this is for 2014 case, and this is actual measurement in the field taken by Water Resource Department. And one important thing that in our analysis, we found that there is 67 villages get inundated or they have damages due to these flood conditions. And their government record is saying that there is 66 villages are inundated during these floods. So that because we have used very precise data in our modeling, so that our modeling results are real matching with actual observations. So this is important when we generate some flood hazard map for any watershed. So consideration of these different parameters is also important. Then only we can get very good results, and that result we can use for actual flood management or practical purpose, planning different response activity. So based on this, because previously we have seen that we have used climate change data to generate flood hazard map in futures. So we have generated these 4 scenarios. That means when there is 5% increase in climate impact due to climate change, 50% increase, 25% increase, or 35% increase. Based on that, we have generated this different hazard map, and how much agriculture area or how much urban area will affect in future, we have estimated. And this is for climate change 35% scenario. This is inundation map, and this table gives how much simulated peak will be there in a future. Accordingly, we can plan some flood management activity like planning of levee or construction of a bridge. We can plan this activity for the future purpose. So that type of study is very important for planning different response activity in the futures. So this is the map for 35% scenario. And so based on this study, the presented various performance evaluation criteria. The performance of HMS model during calibration and validation for Tavi River Basin up to Jammu gauging site attrition is considered very good at Jammu and Sidra gauging station for simulation of discharge and stage hydrograph. However, for Udhampur gauging station, it is considered a good model performance. The calibrated HMS model for Tavi River Basin up to Jammu can be confidently used for flood inundation mapping under climate change. Comparison of flood inundation depth map by HECRAS for lower Tavi River Basin with photographs from campus of Seri Kashmir University of Agricultural Science and Technology of Jammu suggests that the flood inundation depth at the campus is around 35 centimeter and those from HECRAS around 44 to 60 centimeter. So, based on the climate change scenario, the total flood inundated area range between 22,574 hectare to 24,000 hectare for the Indian part, and it is 12,342 hectare for the area that lies in Pakistan. Similarly, the total affected agriculture and residential area will be range between 6,800 hectare to 7,800 hectare in future. And it can be concluded that based on climate change scenario of CC 35%, the flood affected area, agriculture and residential area in the Indian territory in lower Tavi Basin will increase by around 1,700 hectare, 1,100 hectare and 61 hectare as compared to those during baseline period, that is during September 2014. If the we consider this study. This is one case study about the flash flood condition in Tavi Basin. Then we can see another case study that is based on the coastal floods, and this case study of Brahmani Baitani River Basin. And here we are using these HECRAS models, 2D HECRAS models, and then some ocean models like ATAL SWAN model we are using. And then we are using forecasting the tidal effect, sea surges at the river ocean confluence in the Bay of Bengal. So this is the study area. This is the part of Brahmani Baitani River Basin. It is east coast of Odisha. And we require some bathymetry data of ocean also. This is the bathymetry data of ocean, Bay of Bengal. You can see from this picture. And the total catchment area, this is our catchment area, and this is the delta regions. And we have observation at Anandpur and Jainapur. And the total catchment area of this basin is around 9,964 kilometers. And this is the overall methodology. For this purpose, we require some ocean modeling tools like ATAL and SWAN model to estimate the tidal height. And we required some runoff modeling, rainfall runoff modeling, and also across modeling. Then we have to generate coastal flood inundation map. And as I told, for calibration and validation of these flood inundation HECRAS models, we require some inundation map also. So these are the different mathematical equation used in this ocean modeling in case of ATAL and so on. But one case here, to run this ocean modeling, you require supercomputer. You cannot run this on your normal computer. So computational cost is very high in case of this ocean modeling. So we will go direct this modeling framework. So this is our modeling framework. And in this case, we required storm forcing wind field data, then cyclone tracks. Cyclone tracks we can get from IMD. The storm forcing and wind field data is also wind field data we can get from JEPCO. JEPCO is Global Data Agency, or inquiries from inquiries also. Inquiries situated in Chennai. From that agency, a government agency, also we can get wind field or another forcing data from for ocean modeling. So this is the general methodological framework. So I'm not going into detail because it is two-dimensional modeling system, and it run over large area of ocean. So basically, this is Navier-Stokes equations. So this is we require to generate this mesh. It is unstructured finite element mesh. That mathematic data from the general mathematic chart of ocean, that is JEPCO dataset, is used to create the numerical mesh in the there is one software is SMS software is there, and for ADSER and SWAN simulation, the mesh visualization range from 200 meter to 10 kilometer in deep waters, and these are the different tidal constituent. We around 13 tidal constituent we have used as an input data in our modeling system. Is lunisolar diurnal, principal semi-diurnal. Different parameter we require to do this ocean modeling, and then we require wind and pressure forcing. So this is a track. This is track of that Yas cyclone. You are knowing this Yas cyclone. That hello, hello, hello.
Yes,
Sir,
you are.
by mistakenly, someone on the speaker,
Okay,
I
okay.
guess.
No problem, no problem, madam.
You continue, sir.
Then this simulation approach for ocean wave modeling, the model is run for cyclone Fanny that occurred in 2021 and Yas cyclone also. The simulation has been divided into three parts. Standalone, that we call cold start at run with tidal only and non-wind condition. Then standalone hot start at run with initial condition from cold start and meteorological forcing, and then tightly coupled ADSER SWAN, because these ADSER and SWAN modeling are different models. Basically, ADSER's model is used to estimate the tidal height, and SWAN model is used for the simulation of ocean waves, how ocean wave are moving. For simulation of that purpose, we use SWAN model. Both are two-dimensional mathematical models used for ocean modeling, and that run with the tide, wind, and wave forcing. So these are the different time period. We have used around 10-day and 60-year time. For cold start, we have used 10-day time, and for hot start, we have used around 60-day, 63-day with 60-day ramp time, and we have carried out simulation of this ADSER and SWAN model, because we have combined this ADSER and SWAN model, and we have simulated this event for Yas cyclone from 24 May 2021 to 27 May 2021, 3 days, and these are the different parameterization. This computational we have used run this model at 3 seconds, because in case of I have told that in case of numerical mathematical models, computational cost required is very high, because in this case we are running this model at time step of 3 seconds and SWAN model at 600 seconds. That means 10 minutes. And this computational time step is given as input to the model. Then coupling interval for ADSER and SWAN model, because we have using 600 seconds for SWAN model. So we have to couple this interval between ADSER and SWAN interaction. Then the spin-up duration we kept as a 60 days. And then simulation period for cyclone Yas was 3 days, and for cyclone Fanny is 8 days. And for ocean bottom friction, we used this parameter in this ADSER and SWAN models. And in case of near shore, we used 200-meter grid size, and for deep ocean, we used a grid of 10 kilometer. And this grid size decided according to the mesh size functions, because based on this mesh size function, we decided this different size. And these are the results, because we have observed data after every after 3 minute data. This data we got from inquiries, that is sea surge, the height of ocean wave. This data we got from inquiries, and these are the answer observation, blue are observation, and these are numerical simulations. So you can and the result, we have checked this result by running only ADSER model and SWAN model standalone, and then we also coupled this ADSER and SWAN model. And then you can see here, when we couple this ADSER and SWAN model, results are very good as compared to the we use standalone models. So these are the results for Yas cyclone. So we have got a very good accuracy of 83% in case of Yas cyclone. And this is in case of Fani cyclone, we have got master efficiency of 86%. These are the results. And these results we have checked, and these are actual photo, actual simulation results. And we have checked with this satellite picture also. Here you can see the satellite picture and this tracking of ocean modeling, and this satellite image of cyclone Yas source cyclone. And according to our observation, our simulation also reach landfalling at the coast of Odisha. We can check these results also. So these are tracking of that cyclone I at different time, like 25 May at 00 time. After 6 hours, this is the condition. After 12 hours, this is the condition. And during the landfall time at 6 o'clock, this is the condition. And this we can check from this satellite imagery also. So these are the results, different results for this modeling. Then this model, the output of this ocean modeling, we used as a boundary condition in HECRAS, and this is the modeling framework. And we have estimated this flood inundation from using ADSER, SWAN, and HECRAS 2D. Because previously in case of Tagi, we have used one-dimensional modeling, but in this case, we use two-dimensional HECRAS models, and these are the results. This is HECRAS model results during Yas cyclone, and this red color showing the that result we are getting from satellite data, SAR data, that is Sentinel-1 data. We used to extract this flood inundation map, and you can see that how accurately our results are matching. These are the some inaccuracies in satellite map sometimes, because we use change detection methods. So some kind of this dot occurs in satellite images. But in case of inundation extent, in case of modeling system is very clear, because we use very accurate topographic data and input system. So such modeling system we can use to address the problem of flood inundation mapping. So these are my conclusion. Flood inundation mapping in lower elevation zone close to coastal boundary required inclusion of tidal height coming from ocean and entering into the river streams. Flood inundation computed from HECRAS 2D model as the combined effect of storm tides, upstream discharges, and rainfall could reproduce the main benchmark SAR-based flood extent. During the cyclone Yas, the maximum flood depth and the flood area in the Brahmani Baitani Delta, as simulated by HECRAS 2D model, were 8 meter and 1964 kilometers square respectively. That is around 20%. So these are the conclusion. So I think I want to stop here because it is 9 o'clock. So thank you very much. If any question, I'm.
Thank you, sir.
Thank you, sir. It's very informative and energetic information you have given. There is question from my side. Can I ask, sir?
Yes, madam. You can ask.
Can AI and machine learning improve the flood prediction models, and what are the challenges in implementing them?
Basically, madam, there is one study, our study that appeared in Journal of Hydrology 2024, because there is one debate how to use these AI tools, artificial intelligence tools in this hydraulic modeling framework, because you know that artificial intelligence methods that tools are based on input and output. And in AI tools, basically we try to reduce error in input and output series. In that case, we require some observations. But many times, in case of flood, we doesn't have that observation. That's why in case of hydraulic models, we use different empirical parameters. In that case, what I thought that we should not use this AI tool alone to estimate flood inundation. Okay, if we have to generate flood extent map from satellite data like Landsat data or Sentinel data, in that case we can use these AI tools to reduce the noise. Noise means I'm talking about the error. Because like Moody's data that available at grid size of 250 meter, then Landsat data at 30 meter or 10 meter, and Sentinel data is 10 meter. But revisiting period of this different satellite product is different. So we can combine this product and remove noise in this data. We can use this artificial intelligence technique, then we can achieve very good results. That means to support hierarchical modeling framework, we can use AI tools, deep learning or machine learning tools. Another application area, like in case of ocean modeling also, we have used this AI, incorporated these AI tools in that ADSER and SWAN modeling framework to correct the different forcing, wind forcing or tracking this cyclone path. We can use very effectively use these techniques or disaggregation of rainfall events. We can use this AI technique in integration manner with hydraulic modeling tools. But I have some doubt if we use this machine learning or deep learning tool alone, then how much our result is accurate. That's why
Okay, sir.
my opinion, in integrated way, we can use these different tools to enhance
Okay.
our performance, our modeling framework. That is my submission.
Okay. Thank you. Thank you very much.
Thank you, madam.
Dr. T. Babu can ask question.
Sir, good evening, sir. Sir,
Hello.
sir, can you able to hear me?
Yes. You can ask me.
Yes, sir. Yes, sir. Sir, in the recent years,
Mhm.
like southern states are affected
Mhm.
by many disasters like
Yes.
cyclones and landslides in particularly Wayanad area. But
Yes.
we could not be able to predict in appropriate way. Because of that only that incident could be able to avoided or safeguarded the people from that So what kind of remedial measures we can take so that we can advise and we can speak to the government agencies to take care of that thing. So anything model is failed or we could not be able to identify what kind of issues were not addressed by the um, people involved to predict the uh,
If I understand your question accurately, you are
yes, sir.
asking me that how we can use this our technical tool to advise the people and reduce our
Yes, sir.
damages. Right? I'm right?
Yes, sir. Yes, sir.
Because
Yes, sir. Yes, sir.
I also studying these Kerala floods and Maharashtra floods also, Krishna rivers. What problem is that, na? Like in case of you are asking why not? In Kerala state, in 2018 or 21, there is very huge flood in Kerala. And because in Kerala, there is around 80 dams existing in upstream reaches. Because we doesn't have mathematical tools. So when we releasing water from this reservoir in haphazard manner, then if we don't have any good analysis or any study, then this releasing of water from this dam in haphazard manner that creating flood havoc in downstream reaches. And in 2018, same situation occurred because we have to understand two questions here. Because in case of Kerala, that event occurred in September, and in case of India, monsoon season is from June to August, right? So what happened
Yes,
to
sir.
manage this water demand and supply gap? Generally, what that dam people they do, they try to store maximum water during last week of August or September, and that same condition occurred in Kerala floods. And when because when we doesn't have good prediction at that time, very heavy rainfall event occurred over Kerala in month of September, and because almost all the dams are very full at that time, and they starting releasing this water very late. That's why to avoid breaking of this dam, many dam operator might have released a lot of water during that flood event, and it caused a very huge flood in downstream area. Because in case of Tavi flood, I have pointed out one thing, because in case of flashy floods, we get very less response time to evacuate our people. So in that case, we required some good observation points, and at least we go for a very uh, strong modeling framework, because generally in India we doesn't have until now we doesn't have good modeling framework. Like here I have used HECRAS models or HHMS model, then ocean models, and that modeling is required a lot of computational time and expertise also. So my submission is we have to first collect good data, then we have to do good analysis of uh, forecast rainfall, and we have incorporate number of structures, and based on this modeling we should release water in advance. Suppose we release our water from dam in advance at least 2 days, then we can reduce this flood event by around 60 to 70%, and we can reduce our losses significantly. We can reduce, but we have to go for very good modeling and good observation data. We require that, and that's why I told you in my previous slides, that in case of flood inundation modeling, setting up good modeling framework, main problem is we doesn't have good observed data to calibrate and validate our model. And another thing that because this is one part, modeling is one part, but that dam operator have also another pressure, because they have to look the demand and supply of society also. So there is we require some good institutional framework to address this issue, because not only modeling framework, good for modeling framework going to solve our problem, but we have to integrate different economical, social, and that modeling approach to manage this flood very effectively. That is my submission. Thank you.
Thank you, sir. Thank you, sir. Sir, I think, yes, sir, I think
Yes.
some of the parameters they have missed when they modeled that particular area. That may be the appropriate reason. Suppose if we consider certain modeling parameters, then it can be easily predict, and so that we can safeguard the people from the disasters. Like particularly, why I'm telling you this particular again, this particular point here means in Wayanad there is no dam and all. Only it was affected due to heavy rain, landslide, and mudstorm. These three
Yes.
disasters must have happened, but they don't have any dam or anything like that. But
Because
even though they could not be able to predict that particular disaster, many even more than 50 people were died each and every time.
yes,
The
because
government could
last
not
time,
be able to take any appropriate steps to safeguard the people. That is why, if we are able to suggest some more parameters to add the model, I can able to predict exactly so that we can safeguard the peoples. So it is my thought. If the people who involved to model that particular area means if they consider we can have some impact to safeguard the peoples. Thank you, sir.
yes, yes. Thank you. Thank you very much.
Sangram sir, you can ask question.
Hello.
Hello.
Yes,
Sir.
sir, you are audible.
Yes, sir.
Okay. Sir, how
You
can
are audible,
accurate
sir.
the real-time flood monitoring using satellite by using IoT and ITU in HECRAS model?
Because generally satellite data we get at least by 3 hour delay if government agency is there, na? So at least there is 3 hour delay in this data, because they have to analyze this data for accuracy, satellite data, and then particular that authorized agency releases data. So at many time revisiting period of different satellite is different. So many time we miss these events. That's why in previous question also I told that when correcting this data, we can use ML, machine learning or deep learning tools. But until now, the accuracy of this data is not good, that satellite data. And to planning this activity, because in case of flash floods, we can use this data in our HECRAS modeling tools. Not only HECRAS, but there are different packages we can use in our modeling tools. So satellite data we can use for support purpose, because there is 2-3 day flood event of 2-3 or more days duration. Then for planning different activity, response activity, we can use this satellite data. But for planning evacuation, we require helicopter modeling tools, physical modeling tools, or mathematical modeling tools.
Kalyani ma'am, you can ask question.
Hello.
Kalyani madam.
Hello.
There is question from Vinish sir. You can
Hi.
ask Vinish Nair.
Hello.
Yes, good evening.
Good evening, sir.
Yeah, your presentation was very highly informative and it was well organized. Very good. And
Thank you, sir.
yeah, my question is about flood modeling. So,
Hmm.
in the modeling framework, we know the modeling up to that inundation mapping. After
Hmm.
that, you mentioned about that vulnerability mapping. Could you please
Yes, sir.
explain a bit more on vulnerability mapping?
Vulnerability mapping.
Yeah.
Basically, first, before generation of flood hazard map, vulnerability map,
Yes.
we required flood extent. First thing is flood extent. Then we required flood at different places because based on this flood extent, we that parameter is very important, flood depth, because as I told, when depth is 0 to 0.3 meter, that 30 centimeter, in that water we can walk. Then
Okay.
when flood depth increase above this, then when it is 1 meter, then there is less chances that people can die, or only small children can die. And
Okay.
and also duration of that flood extent is also important, because when there is 2 or 3 day depth flood remain for 2 or 3 days, then our building get collapse. So assess this building damage, we required not only depth, also duration of that flood event. So that information we can get from satellite data, or we can get from this hydraulic modeling framework. So this data we require. Then vulnerability is related to people. That means demographic data we require. Different locality, and also economical value of generation of vulnerability map. Economical activity in that particular area is important. Like in Mumbai or any other city, if flood inundation occur for 2 or 3 days, or flood inundation occur in some rural area, then economical losses are very different. Vulnerable
Different.
population is also very different. So we require this basic data, demographic data, then economical activity, and for building damage assessment, we required building curve, damage curve. We can generate damage curve, and based on this damage curve, these damage curve are different for different region, different cities. So we can generate this damage curve, and based
Okay.
on this damage curve, we can estimate this damage for particular area. That's a requirement. Then we can incorporate different infrastructure, because in evacuation we required safe places to move your population. If you are moving to your population to wrong place, then again you are increasing your risk. So that infrastructure and shortest route. Also, by using shortest route, you can evacuate your population very easily. So you have to use optimization technique to find out the shortest route to evacuate your population or livestock. So that
Okay.
information is required to generate vulnerability map.
Yeah, it's clear, sir. It's clear. It's clear.
Yes,
Okay.
yes.
Yeah.
Thank you.
And how many years flood data is required for accurate modeling? I think in your study you used 40-year flood data, right?
No,
In
no, no, sir. Actually, I collected different events
okay.
because I want to study the flood pattern in that particular watershed.
Oh, oh, oh.
That's why from 1977 to 2019 or 2023, I collected big events. So
Yes.
from based on observed data, I sorted out, find out high flood event in particular years, and then I studied this different event
Oh, okay.
to
Okay.
generate this hazard map.
Okay. Okay. Thank you. Thank
Not
you, sir.
40
Thank
years.
you. Thank
Patil
you.
sir, you can ask question.
Hello.
Good evening, sir.
Good evening, sir.
So it was indeed a very insightful and very informative session with various models and data. So we
Thank you,
are
sir.
actually different, belongs to different discipline, even
Yes,
though
sir.
it created interest among us. So my
Actually, sir,
question, we
this
generally,
actually this flood management is interdisciplinary issue subject. So different subject specialists should come together to study
yeah,
this phenomena.
yeah. So it created interest among the audience because
Yes,
of
sir.
your session. We generally talk about the climate change and global warming. So my question is how the climate change will impact on the frequency and severity of floods globally and in India.
Actually, as per our IPCC scenario, they confirm that around 1.3 degrees Celsius temperature has increased. If 1 degree temperature increase, then 7% capacity of atmosphere increase to hold the moisture. That means in future, our number of rainfall event going to increase, and because moisture holding capacity of our atmosphere is increasing, so very high intense spell of rainfall going to occur, and that is also we can see from this data. I have shown this data, global data. So in India, many places number of event per year and intensity is also increased.
Yeah.
So it is going to impact India more as compared to other places, because in India there is a rising trend.
Hmm.
Like places like Rajasthan also there is flood event is occurring in recent year, like last 5 year data you can check. Then you can see there is flood conditions in Rajasthan also occurring.
Oh, yes.
Yes,
So
yes,
we
sir.
can hope
Thank you.
that it will be increasing in future coming year.
Yes, yes, it is going to future because 7% moisture holding capacity per 1 degree rise of temperature is going to occur.
Okay.
So when there is high moisture is available in atmosphere, that means there is a lot of downpour. Rainfall is there. Event of landfall, rainfall is there.
Okay, sir. Thank you so much, sir.
Thank you, sir.
Okay, is there any other question from the participant? I think all the questions are over. So I would like to extend my gratitude for conducting such an informative session on the flood and disaster management and modeling on the behalf of Bharati Vidyapeeth College of Engineering for Women. I extend heartfelt gratitude to our esteemed speaker, Dr. Ravindra Kale, for delivering engaging and informative session. Your expertise and insight have truly helped us, sir. And I would also like to thank all the participants for their active engagement, enthusiasm throughout the session. I have shared the today's feedback link in the chat box as well as on the WhatsApp group. The feedback link is shared, so all the participants feel it. And kindly join for tomorrow's day 4 of FDP session. Thank you all. Thank you, sir.
Thank you very much, madam, for giving this opportunity to me and everybody to listening my lecture very carefully for your attention and your question. Thank you very much. Have a good night to all of you.
Good night, sir. Thank you.
Thank you, sir.
Thank you. Thank you. Bye bye.
Yeah. Bye. Good night.
Thank
Good
you,
night.
sir.
Thank you, sir.
Thank you. Thank you very much. Good night.
Is that session completed? Thank you all. Madam, can we start?
Yes, Sonali ma'am, we will start. Good evening, everyone. A warm welcome to all of you for the day 3, session 1 of online faculty development program on navigating climate variability and impacts for effective water management, disaster preparedness, resilience and mitigation. Program is organized by Bharati Vidyapeeth's College of Engineering for Women, Pune, in collaboration with National Institute of Hydrology, Roorkee. We are excited to share our experience and insights with you.
I think Sheetal ma'am, you're not audible. Sheetal madam, please check your connectivity.
Okay, now my slides are visible to all. I got disconnected due to the internet issue. Now
Yes, you're audible, ma'am. You can
I'm
start.
continuing with the source introduction. Dr. Singh has joined National Institute of Hydrology, Roorkee. He is currently serving as a scientist and is a head of Center of Cybersphere and Climate Change Studies at NIH Roorkee. He is active member of many national international societies in the field of the agriculture and water resources. With more than 26 years experience, Dr. Singh became a recognized leader in hydrology and water resources. His research focus on mainly the topic hydrological impact assessment, groundwater modeling and management, river regeneration. Dr. Singh has guided several postgraduate and doctorate students in the field. He has also published over 65 research papers in national and international journal, contributed to the various research reports, book chapters, and conference proceeding. We are very honored to have you, sir, here. Uh, Dr. Surjit Singh, we will look forward to your valuable insights. Over to you, sir. So you can start sharing your PPTs.
Surjit sir?
हेलो हाँ सोनाली मैम
Yes. Yes, sir, you are audible. Sir, please
हेलो
share your screen.
एम
Sir,
आई
you
ऑडिबल
yes, yes, you are audible. Please
एम
share
आई
your
ऑडिबल
screen. Yes, sir, you are audible.
हेलो ऑडिबल ना अच्छा ठीक है ओके ओके यू कैन कंटिन्यू ओके
Sir, please share your screen. Sir, please share your screen.
अच्छा मैडम अभी इसको स्टार्ट कर रहे हैं अच्छा आपका साउंड दिख नहीं आ रहा है मेरे को यार हाँ नहीं अभी तक तो मेरे को कुछ सुनाई नहीं दिया आपकी तरफ से आप मैं ये हाँ मैं अभी मेरे को अब बोलिए तो आपको हाँ देखिए
Sir, anyone you
अच्छा
want
नहीं
to,
इधर इधर साउंड नहीं आ रही है
sir,
या
anyone
वॉल्यूम
you
भी
want to
इसकी
be
फुल
a
है
presenter, sir?
मोबाइल से पीपीटी में या फिर मैं लैपटॉप से कनेक्ट हो जाऊँ या फिर मैं एक बार देखिए मेरा स्क्रीन कनेक्ट हो रहा है
Yes, it is. It
अच्छा
is visible, sir.
अच्छा
Your
लेकिन मेरे को
presentation
आपकी
is
साउंड नहीं आ रही
visible.
मेरी साउंड आ रही है अच्छा लेकिन इधर आपकी साउंड नहीं आ रही है अच्छा मैडम देखिए इधर 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 साउंड नहीं आ रही है स्क्रीन तो मैंने सेट कर दिया है लेकिन उधर से साउंड नहीं आ रही है साउंड आप क्या आ रही है मेरे को आ रही है उधर से नहीं आ रही है जैसे ये वॉल्यूम भी फुल है इधर से शेयर नहीं हुआ है ना हुआ है शेयर तो अभी कर दिया मैंने इसकी हाँ शेयर तो है इसमें ये सोनाली जी वजह से बोल रही है ना तो इधर कुछ साउंड नहीं आ रही है अच्छा आपकी इस पे आ रही है नहीं मुझे आपकी आवाज आ रही थी मैं देख सोनाली की आ रही है सोनाली की नहीं उनकी नहीं आ रही हाँ तो उनकी तब कुछ प्रॉब्लम इशू है मेरे को भी नहीं आ रही बात करके हाँ ठीक बैठिए बैठिए हाँ हो पण इथे इथे ना तुमचा आवाज येत नाहीये सरांनी स्क्रीन पण शेअर केली आहे पण तिकडे दिसत नाहीये
एक मिनिट, मला वाटतं पुन्हा लॉग आउट होऊन करू दे का एंट्री?
Sir, your PPTs are visible.
नाही, पण आता ह्याच्यावर येतोय का?
शीतल मॅडम, त्यांना आपला आवाज जात नाहीये, सो वी हॅव टू वेट.
आपण घ्या रे.
हा हा, परत कर. एक बार फिर से लॉग इन कर लेते हैं। अच्छा, इसमें कभी ना कभी गड़बड़ हो ही रही है। मुझे लग रहा है सर इसका माइक ना चल नहीं रहा होगा। नहीं, लेकिन माइक चल रहा था आपके आवाज आ रही थी। उधर से नहीं आ रही। हाँ
Sir, it is audible? I think there are some network issues. Sir are again rejoining. Anjali, just let him allow.
Yes, yes, I will.
मैं तो कनेक्ट हो गई। फिर साउंड आ रही है आपको? सुना नहीं।
सर अभी आ रही है आवाज आपको?
अच्छा, आप इससे बोलिए, इधर से आ रही है?
ये स्क्रीन करूँ या विंडोज शेयर करूँ? पीपीटी ओपन है क्या?
स्क्रीन, हाँ स्क्रीन शेयर कर दीजिए। अच्छा, पीपीटी में ओपन कर दीजिए। पीपीटी में ओपन कर,
स्क्रीन ना शेयर हो जाए, पीपीटी ओपन कर दीजिए।
स्क्रीन शेयर कर सकते हैं।
Sir, can you hear us?
इसको मिनिमाइज कर दीजिए, इसको बाद में कर दीजिए।
हाँ हाँ हाँ।
Yes.
Sir, ma'am, you are audible. Just a minute, we are doing. हाँ.
Okay, okay.
स्क्रीन शेयर कर दीजिए।
इसको
Is it visible now, ma'am?
Yes, 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 it is visible.
It's in full screen now.
Yes, yes. Can you hear us, ma'am?
Yes. हाँ 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 हाँ।
साउंड
को नहीं आ रही है ना? हाँ। सर को साउंड नहीं आ रही है एक्चुअली।
Okay.
आपकी साउंड सर को नहीं आ रही है।
इधर आपको आ रही है?
हाँ, फोन में आ रही है। मुझे आ रही है।
अच्छा,
आपको नहीं आ रही। मुझे भी थोड़ा सा इसमें से एक बार चेक कर लो। साउंड शेयर साउंड। हाँ, ये क्लिक कर।
हेलो हेलो, सोनाली जी।
सिस्टम में नहीं आ रही इसकी।
Yes, sir. You are audible. Dr. Surjit sir, you are audible.
हाँ, उनको आ रही है आवाज। फिर आप चाहे मोबाइल से।
हाँ, अगर कोई क्वेश्चन लेना हो तो फिर वो मोबाइल से ले लो। सोनाली जी,
क्योंकि मेरा भी वही प्रॉब्लम हुआ था।
अच्छा,
गड़बड़ है।
अच्छा, इसकी वजह से प्रॉब्लम पहले थी आती, उसकी तो लैपटॉप उसमें कनेक्ट किया था।
अच्छे से आता है
लैपटॉप में उसमें मेरा लैपटॉप वीडियो नहीं आता, साउंड तो आ जा रही थी। और तो उसे कर सकता हूँ,
कर सकते, लैपटॉप से भी कर सकते।
हाँ, तो लैपटॉप से कर सकते हैं।
पैरेलली आप कनेक्ट कर दीजिए सर, दोनों तरफ। हेलो, हाँ सोनाली मैम, जस्ट अ मिनट। सर को आपकी साउंड नहीं आ रही है।
Hello.
हाँ हाँ मैम, सर को आपकी साउंड नहीं आ रही है, तो थोड़ा सा एक मिनट, या तो वो लैपटॉप से कनेक्ट कर लो।
Okay, ma'am.
तो सर आप
Ma'am, can you just take the speaker setting?
Yes. It is there, but I don't know why you are not audible here in search screen. You are audible to mine, but not.
Hello, Sonali madam.
Yes, yes, ma'am. Hello. Ma'am, sir is not audible.
He's connect. Hello.
Hello.
He's
He's
connecting from
connecting
some
from
other
some other.
room, from the laptop. Audible now? Hello.
Sonali ma'am,
Yes, sir.
now I am audible
Yes, yes.
and myself visible.
No, no, right now you are not visible, but you are audible. Yeah, right now you
Now
are.
visible.
Yeah, yes,
Okay.
yes.
Okay. So
Okay.
now I am sharing my screen. Okay.
Okay, sir. Okay.
So my presentation visible now. Hello.
Yes, yes, sir.
Yes, sir.
Your
Yes, sir.
PPTs
Yes,
are
sir.
visible. You are audible, and your
Okay.
video is also visible.
Okay. Okay. Fine, madam. So should I now start?
Yes, sir. You can start.
Okay. So
Yes.
good evening. Thank you, madam. Good evening to all the participants and organizers. So now I am starting my lecture on assessment of water availability and quality in the era of climate change under the ATAL Faculty Development Program on navigating climate variability and impacts for effective water management, disaster preparedness, resilience, and mitigation. So this is the presentation outline. So little bit I will present on background, then water availability and trend in water availability, then impacts of climate change, then future projections, adaptation strategies, assessment of water availability, water quality assessment, enhancement of water availability through water harvesting, and then concluding remarks. So this is the global water volume. So from this figure, you can see that if we start from oceans, so in ocean there is 1350,000 kilometer cube of water. Means 1 kilometer cube means 1 billion cubic meter. So we can call 1 kilometer cube equal to 1 BCM. So here you can see that total evaporation from the ocean surface takes place for lakh 25,000 billion cubic meter of water. And when this water evaporate from the ocean surface, then again through precipitation in it comes back on the ocean surface on itself to the amount of 3,85,000. So you can see the net difference between 425 and 385 means 40,000 billion cubic meter of water is transported from ocean towards the land surface. And there is also water vapor in the atmosphere around 13,000 billion cubic meter. Then when this transport of water of 40 billion cubic meter towards the land surface, then in the form of precipitation, means precipitation includes both rainfall and snowfall. So precipitation on land surface takes place 111,000 billion cubic meter. Then again from the this ice and land surface, again 71,000 billion cubic meter water goes in the form of evaporation and transport and transpiration in the atmosphere. So again, if we see the difference between 111 and 71, so it is 40,000 billion cubic meter, and again so in the form of rivers, this water 40,000 billion cubic meter again goes back to the oceans. So we can see that there is net around 40,000 billion cubic meter transport of water from ocean to land and then again back to the oceans. So this is again the replication of the same figure, but here are some distributions. So if we see that total water availability, then in ocean there is 96.5% of global water volume, while land surface uh, consists of 3.5% of the total water surface. And here you can see that 33,000 billion cubic meter water is available in the form of ice. Here, this much water is available in the form of ice, and this is land evaporation. And this ice, and there is also some water available in the form of soil water, means above the groundwater table from the earth surface and underground water table. In between, there is soil water, and if we see the total ice water, soil water, and groundwater, then it is 48.422 thousand billion cubic meter. So this is basically the total. If we see the total global water volume, then it is 1385.5 thousand billion cubic meter. If we talk of India's water balance, then annual precipitation is around 117 centimeter, around 120 and 117. So if we multiply it with the geographical area of our country, then around 4,000 billion cubic meter. As I told earlier, that 1 billion cubic meter is equal to 1 kilometer cube. So this much volume of water every year comes to the earth's surface in the form of rainfall. And out of these 4,000, 3,000 billion cubic meter comes in the 4 monsoon month, and rest of 1,000 billion cubic meter water comes in the form of precipitation in the of the monsoon season. Then of this 4,000 billion cubic meter, the 430 around 431 billion cubic meter water goes to the groundwater recharge, means that is seeps into the our earth surface, and 1540 billion cubic meter goes in evapotranspiration and balance. Average annual natural flow to rivers and aquifers, it is 1869 billion cubic meter. So the total available water is around 2300 billion cubic meter, 2300 billion cubic meter. And of this available water of 2300 billion cubic meter, utilizable surface flows are 690 billion cubic meter. Rest water is 1179 water goes in excess runoff. We cannot store this water. After storage in dams, reservoirs, this water goes in the rivers and ultimately joins the oceans. And utilizable groundwater is 397 billion cubic meter, and rest is around 36 billion cubic meter. Water is natural discharge or base flow. So sometimes this water comes in the river, or also in coastal areas there is natural discharge to the oceans. So this utilizable groundwater of 397 and utilizable surface flow is around 690 billion cubic meter. The total available water for use is 1123 billion cubic meter. Around 1100 billion cubic meter water is available for countries' use, including both surface water and groundwater. And this much water, around 1100 billion cubic meter, it is around 28% of the average annual rainfall. And our country's current water use is 634 billion cubic meter. Means our country's is using presently 634 billion cubic meter, and supply is 1123. So the surplus water we are having 489 billion cubic meter. So presently we are surplus in overall water balance, but because of increasing population, growing demands, industrialization, urbanization, so this demand is goes on increasing, but the average annual rainfall is almost fixed. So supply is fixed, demand is increasing. So in the coming future, we may go in deficit in terms of water availability. So what is the water availability? Because water availability is not fixed. It is not like that we uh, keep our money in bank. So that is fixed. That is not, there is no loss. But water availability means if we store water in the form of reservoirs, dams, so it is dependent on the on many factors, but broadly it is dependent on the rainfall. So in some year the there is very good rainfall, but in some years there is deficient rainfall. So on an average it is changing. And also when we store water, so a significant amount of water goes in the evaporation. So that is lost in the form of evaporation. So basically the water availability, we do a dependable analysis. I will explain in the following slide how we estimate the water availability. So basically it is a probabilistic term, and with the more and more probability we estimate the water availability. Like for drinking water, we estimate depending upon 90% probability, assured probably we should get for drinking purpose, but for irrigation and we estimate water availability depending upon the 70% probability. Then why government need to assess water availability? Because government has to supply water to various cities, industrial areas, and also for
Sir, you are not audible. I think you have muted yourself.
Yeah, it was muted. I think I might have clicked on the screen. So now I am audible.
Yes, you're audible, sir.
Okay. So why I was telling that why government need to assess water availability, because they have government has to supply water to various cities for drinking water supply, for industrial use, and also for irrigation. So how much water will go for irrigation? How much go for industrial use? For how much we should get assured water for drinking water supply? Because we cannot compromise with the drinking water supply. So how at the end of the monsoon period, how much water is available with the defined probabilities. So that is why we need precise assessment of water availability. So what will happen if water availability declines? So if the water availability declines, then we cannot meet the country's demand. So next question is poor quality water is part of water availability. So I can say that poor quality water is not available, is not part of water availability, because there are standards for in terms of water quality for drinking water supply, also for irrigation purpose. So if water is contaminated, so that cannot be supplied for drinking purpose, not cannot be supplied for industrial use, and cannot be supplied for the irrigation purpose. So that water is normally excluded. But after recycling, and we can use for certain purposes. But again, there are many concerns regarding acceptability and guidelines. So is water availability is uniformly distributed throughout the country? So the water availability is not uniformly distributed. Some areas are water surplus, some areas are water deficient, like the rivers originating from the Himalayan region. So the northern India, they are perennial. So the northern India, it has surplus water. But as we go towards the central or southern India, so because of the rocky terrain in that region, they are not water surplus area. So the water availability varies from place to place. Can the water availability be increased? Yes, water availability can be increased. I will show in my slide how we can increase the water availability by protecting from pollution, and also from the rainwater harvesting, water creating water storage structures. Then how to increase, so I will show the slides. And what will be the impact of climate change on water availability? As all we know, because of climate change, there is likely that the temperature will be rising, that there will be change in precipitation. Some areas may get higher precipitation, and some areas may get low precipitation. And also the whenever the rainfall may be more intense, so much of the water may come in very intense rainfall, and that will go as a runoff, as a waste. So it will get less time for groundwater recharge, and also we cannot store more water in a very short time. So there are concerns related to this climate change. We have to adopt certain adaptation strategies to cope the climate change. Then total water availability, it is comprises both surface water availability and groundwater availability, and equality is equally important. The surface water resources include rivers, streams, creeks, lakes, wetlands, and reservoirs. It is an important source of drinking water and is used for, as I told, irrigation, industrial, and other public usage. And availability of surface water varies depending upon the precipitation, storage capacity, how much storage capacity our country has created in the form of reservoirs, dams, ponds, so, wetlands, artificial reservoirs. Then it also depends upon the permeability of soil. If the soil is more permeable, so it will more water will seep into the ground and enhance the groundwater resource. And then runoff characteristics of land. If there is more concreting, or the runoff coefficient is less, so more water will infiltrate into the ground. But if the runoff coefficient is less, then more water will go in the form of surface runoff, will flow on surface and will join the rivers. And the timing and pattern of precipitation, how the rainfall, if it is a very intense rainfall, then much of water will go in the form of surface runoff into the rivers. But if the rainfall is slowly it is falling, then the much of the water will go into the recharge in the form of to the groundwater water recharge. And if the rainfall is concentrated in India, we are having broadly 4 monsoon month. But if suppose the most of the rainfall takes place in 1 month or 2 months, then it will have many concerns to the reservoir storage, because they have certain rules that in July this much storage can be, the reservoir can be filled up to certain level in month of July, and then up to a certain level in the month of August, then September. So there are rule curves for storing water. But all of water falls in the, for example, in the month of July. So the dam authority will not complete store the water because they will anticipate that in the month of August, September, there may be more rainfall. So again, we have to open the gates all of sudden. And so it may create downstream flooding. So slowly they fill the dams and reservoirs. So the distribution, if the 4 month, suppose if the 4 month monsoon month rainfall is distributed throughout the year, then we need not to store much water in the reservoirs, because every month we have some surety that we will get rainfall. So because we get rainfall in the 4 monsoon month, and we have to meet our demand from that 4 month storage water. So that's why the planning comes in picture. Then water availability and potential. For assessing the water availability of our country, the entire country has been divided into 20 river basins. These basins comprise of 12 major river basins and 8 composite river basins. So this is the list of 20 river basins, and what is the catchment area of these river basins, and in each basin how much is the water availability. So the last column you can see, and the total water availability you can see, 2115 billion cubic meter is available in our country. Then India receives average annual rainfall of 3729. I told earlier broadly 4000 billion cubic meter. So now it is updated figure. And major dependency of the annual average precipitation is from southwest and northwest monsoon. Most of the precipitation takes place from the southwest monsoon during 4 months, June to September, except in Tamil Nadu, where it is from northeast monsoon during the period October and December. There is a considerable spatial variation in the precipitation, from less than 100 mm in the western Rajasthan to more than 2500 mm in the northeastern states. Northern region of our country is blessed with higher availability of surface water because of perennial nature of rivers, because these in the northern India, many of the rivers, they originate from the Himalayan region. So as the summer season starts, so the melting of snow and glacier takes place, so again the flow increases. So the rivers in the northern area, they are perennial. The perennial Himalayan rivers and seasonal extra peninsular rivers together carry more than 70% of the total available water resources in our country, and leaving the available water resources in the peninsular region to 30%. The regional disparity in the distribution of rainfall, along with the temporal variation, leads to simultaneous occurrence of floods and droughts in the country and adversely affect the quantum of utilizable water. So we also feel that sometimes some part of our country is reeling under drought, and some part is uh, suffering from extreme floods. So because of the climate change activity, these severities are increasing. And as per a study by Central Water Commission 2024, country's annual average water resources has been assessed as 2116 billion cubic meter for the reference period of 38 years from 1985 to 2023. So it is 2116 is the annual average water availability. And top 3 river basins with highest water availability in our country are Brahmaputra, 592 billion cubic meter availability water, Ganga, 581 billion cubic meter, and Godavari, 129 billion cubic meter. Due to high population density, Ganga basin is water stressed, while Brahmaputra and Godavari are relatively in better situation. The bottom 3 river basins in terms of water availability are Sabarmati, Pennar, and Mahi basin, which is primarily due to comparatively lesser catchment area and moderate rainfall. Where higher population density, these basins also face water stress sometimes. And the utilizable water resources of our country is 690 billion cubic meter from the surface water. And around 45% of the available water resources in peninsular India are utilizable, and corresponding percentage for North India is 33%. As per the CWC report on reassessment of water availability in India in 2019, per capita water availability of India was 1486 cubic meter. Means this is the per capita water availability, which is categorized as a water stress condition according to the Falcon Mark water stress indicator. And you can see in both these figures the precipitation, the moving average in the precipitation as well as in the water availability of our country is showing a declining trend. Then these are the potential impacts of climate change and surface water. So projected increase in frequency of climate extremes means intense rainfall, uh, droughts. So intense rainfall, they also sometimes create flash floods and extreme floods. And due to warming, these may further reduce the potential of utilizable water resources. And high intensity precipitation in the catchment areas of storage reservoir exceeds their capacity, prompting the opening of gates. Because if the high intensity rainfall is taking place in a catchment area of any reservoirs, so spontaneously they are forced to open the gate because a lot of runoff volume will come into the reservoir. And if the reservoir is not kept some cushion or some is not make some empty for absorbing the catchment runoff, then it may overtop the dam and there may be dam breach. So which causes accelerated and when we promptly open the gates, then it accelerates flows in the downstream areas and consequently it is the wastage of water. So past occurrences of floods in Kerala, Chennai, Gujarat, Hyderabad, in many states are the example of surface water getting wasted without being able to conserve for drought period. Another significant threat to surface water resources is pollution from point and non-point sources. Climate change can exacerbate pollution of water resources. Urban floods can lead to mixing of sewage and industrial waste with surface water resources. So whenever the urban flooding takes place, so the sewage water and basically there are separate storm drains and separate sewage lines. So sometimes they're mixing because the flooding, the mixing takes place and it ultimately goes to the our rivers or some downstream water body and it's contaminate our rivers and lakes, water bodies, etc. So snow and glacier melt also play a significant role in the Himalayan rivers. The importance of glacier melt is that it contributes more water during drought years because of melting of glaciers and fewer water during flood years, thereby balancing and maintaining the water availability in the basin. So we can see that how snow and glacier melt, glaciers are important to our country in contributing water during droughts and flood years. Literature shows that Himalayan glaciers are retreating and experiencing negative mass balance. Negative mass balance means the melting of glacier, accelerated melting of glacier is taking place. So sometimes there is positive mass balance, sometimes there is mass balance. So in general, broadly, there is negative mass balance. So positive mass balance means glaciers are expanding and negative mass balance means the glaciers are reducing. And the rate of loss has increased in the recent decades owing to the temperature increase because of this global warming. Then availability and potential of groundwater. As per the Central Groundwater Report on Dynamic Groundwater Resource of India in the year 2024, the total annual groundwater recharge in the country has been assessed as 446 billion cubic meter, while the annual extractable groundwater resource is 406 billion cubic meter. Means what does it mean that we have total groundwater availability as 446 billion cubic meter, but we can extract only 406 billion cubic meter. Rest we cannot, means 40 billion cubic meter we cannot extract. Means our net water availability is how much? 406 billion cubic meter. That is that we can extract through tube wells or whatever it is. And the annual groundwater extraction in 2024 was 245 billion cubic meter. So means 406 minus 20, 406 minus 245, this much we are having surplus groundwater available. Agriculture sector is the largest consumer of groundwater resources, means 87% of total extraction is in the agriculture sector. So a small saving in the of water in the agriculture sector, it may save huge water, which amounts to around 213 billion cubic meter. And domestic use is around 11% and industrial use is 2%. So you can see we are for domestic purpose it is 11%, for industrial use it is 2%, but for agriculture sector it is 87%. So you can see how much water is used in our country in the agriculture sector. The average percentage of utilization with respect to annual extractable resources for the country as a whole is about 60%. Means it is the if we divide the annual groundwater extraction of 245 by 406, so it comes around 60%. So of the total groundwater availability, we are using 60%, but 40% still we have as surplus water. But in this water availability will go on decreasing in future because of more and more demands and also withdrawal of groundwater. So main source of replenishable groundwater resources recharge, means how the groundwater, the main source is rainfall, and 60% of annual groundwater recharge is recharged from the rainfall itself, and rest is recharged from other sources like from rivers, canals, irrigation, reservoirs, and more than 75% annual rainfall is received as I told earlier in 4 rainy season months, June to September. So it leads to large variations in the temporal scale. So the groundwater availability also varies from place to place, and type of rock formations and their storage and transmission characteristics have a significant influence on the groundwater recharge. Means what type of soil formation, rock formation, so how much water will recharge, and how much water we can extract again from after recharging from groundwater. So it all depends. And porous formations such as alluvial formations in northern India or in coastal areas in the Indo-Ganga Brahmaputra basin have high specific yield. Means if the specific yield is high, then we can extract more water from our groundwater reservoir. But if the specific yield is less, like in the hard rock area, then we can extract less groundwater. And groundwater occurrence in the fissured formations occupying nearly two-thirds of the geographical area of the country is mostly limited to weathered, jointed, and fractured portions of the central and many of the southern region. They are the formations are rocky type, so the water is present in the weathered or jointed or in the fractures only. But in northern India, in the alluvial part, we get water. The groundwater is present everywhere, but in the hard rock area, it is in the limited fractures, weathered portions only. Then next is the potential impacts of climate change on groundwater. So climate change alters the frequency of climate extremes, which will affect soil moisture, groundwater recharge, and finally the groundwater level will be affected. Fast withdrawal of water due to pressure from the rapidly growing population will reduce the recharging time of aquifers and further will deteriorate the groundwater levels, and which will aggravated by the impact of climate change. And these are some of the future projections with increasing population and a possible shift from an agrarian to an industrial or service-oriented economy. Demand for water resources in India will jump in future. And alarming rate of groundwater depletion, the variability in precipitation coupled with the uncertainty of climate change, inefficient irrigation water usage and deteriorating water quality on the one hand and escalating water demand on the other side depicts the grim reality of future water crisis in our country. Projected per capita availability for the year 2031 is estimated as 1367, which will further decrease to 1228 cubic meter by around 2050. Means 2051 is the year when the country expects that our population will stabilize. And projected water demand for the year 2050 is estimated as 1180 billion cubic meters. So we can see that how the demands are increasing, per capita water availability is decreasing. And these are the some of the adaptation strategies to withstand the climate change. So, strategy to mitigate water stress due to climate change and increase availability of usable water may be done by reducing the wastage of water, increasing water harvesting capacity, and increasing groundwater recharge. So if we create more storage capacity underground or in the form of dams and reservoirs, and we protect water from wastage and pollution, so we can mitigate to some extent the impact of climate change. Then next is effect of reduction in rainfall due to climate change could be mitigated through better water harvesting by creation of micro storage facilities in watersheds. Then lining up water conveyance systems. Many of our canal system, they are not lined with cement concrete. So a lot of seepage also takes place to the groundwater. So by lining, we can protect some of the losses of water and they also lead to waterlogging. And the existing large reservoir operation policies need to be redeveloped, and demand patterns are likely to be affected because of climate change, because if the temperature will increase, so the demand of water for crop will also increase. For example, suppose if any crop requires irrigation in 15 days, so if the temperature are rising, so there is likely that the crop will need irrigation maybe in 10 days or 12 days. So number of irrigations will increase, and ultimately it will require more water and water availability will be affected. Then the policy also need to be developed for real-time operation of reservoir for mitigating the floods. Then conjunctive use of surface water and groundwater also needs to be planned for irrigation and under changing climatic conditions. Then interbasin transfer of long interbasin transfer of long distance uh, or and water trading may increase the water availability. In our country, many schemes are in process, like interlinking of rivers. So many of the surplus rivers, they are being interlinked so that the water can be transported to the water scarce areas. And also we need to treat effluents properly so that wherever we have good quality water, that is not gets polluted. Then water serves multiple uses and users. Effective interdepartmental coordination in the government is needed to develop location-specific framework for sustainable water management and optimal recycling of water. So these are some of the other management practices at the farm level, because much of our water is consumed in the agriculture sector. So we save a small quantity in the agriculture sector, so huge water will be saved. So there is some on-farm irrigation hydraulics, like if we have a well-labeled farm, so it will be irrigated in less amount of water. So if we do proper land labeling methods, follow and designs, so we can save water to some amount. Then micro irrigation systems like drip and sprinkler irrigation, and we are having some sensor that so that we can optimize when to irrigate, sensor based monitoring of the soil moisture and evapotranspiration. So they can also there can be a well planned irrigation system, then cropping pattern. So in many areas the there is rice cultivation, and rice is a very has very heavy requirement of water. So we should grow rice in the water surplus area, but the water scarce area we should avoid rice or paddy cultivation. Then adopting cropping patterns suited to agroclimatic zones, reducing water demand, especially in water intensive industries and household. Biotechnology may help in increasing crop yield by reducing water requirement and developing crops that are less dependent on water, spread of drought resistant crops, then improvement in groundwater use by recharging, rainwater harvesting, etc. Then there are development and management options like evaluatory measures. We should also, because in agriculture sector there is in mostly majority of area there is flood irrigation, so there is no proper assessment and monitoring that uh, how optimally any crop can be irrigated and how much water can be saved, or how much water is consuming in different crops. So and there is the corrective measures at artificial recharge, water harvesting, including rooftop rainwater harvesting, subsurface drainage, conjunctive use, watershed development, increasing storage capacity, interlinking of reservoirs, construction of dams. All those are the corrective measures, but then there are some protective measures, means effluent treatment and safe disposal of pollutants, means the polluted water should be treated, and after there are also standards that before discharging water in any water body or rivers, the water should be treated up to certain standard, then only it should be discharged into the water bodies. Then floodplain zoning, flood forecasting systems, flood insurance, food preparedness, preparedness, technological management. Then there are some regulatory and legislative measures like formulation of water resource development and use policy, convergence of funds available to various programs and water resource development. So there is optimal utilization of money in the water sector. Then ensuring gender equality and participation of women in decision making, particularly in the rural areas. Then crop insurance, so that the farmers they are secured, they and avoid unnecessary losses. Then expanded use of economic incentives to encourage water conservation, and heavy levy of water wastage and overuse. We should incentivize to those who use the practice of water conservation. Then other adaptation measures are enhanced water storage capacity. We see the per capita dam storage capacity in India is one of the lowest in the world, means 2000 meter cube per capita as compared to 5000 meter cube per capita in USA, 1000 in China, 900 in South Africa. Then capture glacial and snow melts. It is predicted that global warming in the tropics shall cause enhanced deglaciation and snow melts during next 7 to 8 decades in the northern Himalayas. So this calls for effective capture of these additional resources to tide over the subsequent reduced supplies and mitigate the impact of flash floods. Then intervention transfer, as I told, so intervention transfer are most likely inevitable. The government of India has already developed a national integrated water development plan and national river linking project for transfer of water from relatively water rich eastern Himalayas to deficit southern basins, and lot of work is going on. We have NH has already completed the feasibility study of two links, Mahanadi Godavari link and the Farakka Sundarban link is also very shortly being completed, and some other reserve interlinking projects up to Tamil Nadu, they are in process. Then there are mitigation measures. Mitigation measures on individual structures can be achieved through improved design standards and performance specifications. Then water productivity, we have to increase water productivity, which is needed at all levels through field, farm, and command areas and basin level improvements, multiple usage of water, ensuring hydrological sustainability of intensive cropping systems, reducing non-beneficial evaporation losses, breeding drought, flood tolerant, and water efficient cultivars, and community participation in resource management shall help in demand management of the water resources. So this is how we estimate the water availability at any point on the river or any water body. So water availability assessed by estimating dependable flow volumes at various probability levels using flow duration curve technique. So first, what we have data series. Means what is the water availability can be estimated on weekly basis or monthly basis or annual basis. So first we need to arrange the data on we want to estimate on monthly basis. So what is the month wise discharge available in a river at any point. So all these data are arranged in decreasing order of their magnitude. Then the probability is estimated using the formula P equal to m divided by n plus 1, where m is the order number of the event and n is the total number of data points. So the greatest data value should be ranked as number 1 and the second number 2 and so on. So using this formula we can estimate the water availability, and in literature is available. If you and anybody needs any examples, we can also provide that. So it is the example of a monthly water availability. So monthly water availability for agriculture purpose shall be estimated at 75% probability, while for drinking purpose it should be estimated at 90% probability, because we need that 90% assurity water should be available for drinking water supply. But for we may not need that much probability in the agriculture sector, because public cannot survive without drinking water supply, so the probability is high. So every month we can estimate the water availability. So using the previous slide, for each month you have to arrange the data points, and then we have to estimate the probability, and then we can plot. So we can see that from June to October, you can see the lot of monsoon rainfall takes place. So the water availability is high in those months, from increases from June to October, and the rest of month very less water availability. So that's why we need storage in the form of reservoirs, dam, etc. So here again we can see it is the annual water availability. So as the you can see the bottom line, the 10%, 20%, 30%, and so as the probability increases, water availability decreases. In the you can see. So because if we want water availability as 20%, so that may not be more reliable. So the as we are more we want to more ensure that we want 100% water availability. How much is the 100%? So you can see the at 100% it will be minimum, but as we if the probability is less, then the probability increases, because if we reduce the probability, then there are not chances that you can meet that demand. But if you want to meet 100%, then you need probability of 100%. And so this is the BIS guidelines for evaluation of water quality. So Bureau of Indian Standard 10,500 in 2012, they have modified the water quality guidelines. So you can see the first column, it is the parameters. So there are number of parameters: pH, EC, temperature, bicarbonate, and then ions, and then metals. So and there are two types of limit: acceptable limits and permissible limits. So acceptable limits are where we have the water source available, but in certain areas water source may not be available. We need to transport water through canals or piped water supply or through tankers. So in that area there are some relaxed standard. Means acceptable limit is some these are stringent, and they are permissible limit, they are relaxed limit. So accordingly you can evaluate the water quality, how the water quality is for surface water, any water. You collect the sample, test in the laboratory, you will get these water quality parameters, like whatever parameters you test in the laboratory, like pH, EC, temperature, bicarbonates, ions, metals, and then when you test, just like it is just like we go for a pathology lab and test our blood, and then what are the standard values, what are their range. So if the ranges are violated, means we say that these parameters are increased and we need to treat. So accordingly, it is the water quality. So you get the parameters from laboratory, and then you can compare with the acceptable permissible limit. If these the limits are exceeding, the sample limits are exceeding, so we can say that these parameters are violating the standards and we need treatment of that water. So for example, you can see some site 1, 2, 3 in yellow color. This is the sample collected from certain sites and then compared with the BIS limits. So and that slide, it is the riverbank filtration site in Agra district. So what are the minimum value? Because number of samples were collected at different times from a particular site. So all the parameters, it was difficult to present, but we have uh, shown that what was the minimum value, what was the maximum value, and what was the average value for different sites. So the red color value shows that these are exceeding the Bureau of East Indian Standards values. So like here you can see in the red color values are the last column indicates the BIS standard, and these values are exceeding in those limits. And we can also be normally we what we do, we also evaluate the surface water quality separately, groundwater quality separately. Uh, and we can also if we have a more number of data point, we can also estimate that how much data points are falling within 90% uh, and how much are exceeding. And sometimes there may be that most of the parameters of a particular site, they are within the range, but sometimes maybe in the summer season, if there is low flow, then because of some pollution, the parameter increases. So based on the burn time or burn value, we cannot say that the water quality of a particular river or water body is not suitable. So there are number of guidelines how we should evaluate the water quality. Then you can also plot this kind of pie charts for major ions chemistry. So we can say the upper portion is showing for river and bottom for groundwater. So we once we test the water samples in the laboratory, then we plot the pie charts and we say that whether bicarbonate are dominant or sulfate are dominant, or sodium is dominant, fluoride, chloride. So all these are the anion and cation chemistry. So we classify that the any particular water, what is the anion and cation chemistry of the water. So it is a bicarbonate dominated or calcium magnesium dominated. So we can plot this kind of plots and we can assess the water quality. Then another technique is, number of techniques are there. So I have presented some of them in the Piper diagram. So there are some softwares like Aquacam, Rockworks. Using those software, we can develop this kind of chart. And so basically, these kind of charts are used for evaluation of the water chemistry, that what is the phases of water, which kind of ions are present in the water. So likewise, we can also we have the data of metals, so we can also compare from BS where any metal or fluoride is exceeding or iron content is more. Sometimes from groundwater, from hand pump or tube well, we store water in a vessel, and after some time it gets some yellowish color. So it indicates that iron is more in that water. Sometimes so when we boil water and keep for cooling, then some salt are settle at the bottom. So means that is having more tedious. So likewise, this is also a Duro diagram. So what kind of water chemistry any particular water sample is indicating. So it is used for that. Then in the rivers or groundwater, whether if there is water is near to sea, so if there is any mixing from sea water or sea water intrusion is there, or the water is indicating evaporation dominance, or if it is a precipitation dominance or rock dominance, means it is interacting coming in the hilly areas if the water is coming from rivers, and also from groundwater, contributed from groundwater in the form of base flow. So what water is indicating which kinds of parameters TDS or ions are present. So we use this Gibbs diagram, we plot, and we can see here that in which zone it is falling. So accordingly, we can say that it is rock bathing dominance, or it is a fresh water, or recently recharged water, or it is precipitation dominance, or saline water, which kind of water. So accordingly, we can conclude on the water samples. Then there are different kind of plots. We can plot 1:1 plot of calcium plus magnesium on vertical axis, bicarbonate plus sulfate on the horizontal axis, and this is the 1:1 plot, means vertical axis, and horizontal axis you can see the 10 units. So it is a 1:1 plot. So if the water is falling above the points falling above this line, they indicates the reverse ion exchange, and below this line 1:1 plot, it indicates ion exchange is taking place in the water. So we can change the parameter, like in the second it is calcium plus magnesium vertical axis and bicarbonate on the horizontal axis. So above this line it indicates extra sources of calcium and magnesium ions, and below this line suggests the reactions of feldspar minerals with carbonic acid, and along this line it is a dolomite weathering. So likewise there are different plots what they indicate. So what the calcite dissolution produces calcium ion, while dolomite dissolution produces magnesium ions. Basically these are carbonate kind of rocks. And iron exchange process, where ions attracted to rocks are exchanged with the bicarbonate in aqueous solution, produces bicarbonate and sulfate. While in reverse ion exchange process, where calcium and magnesium ions in the aquifer matrix are replaced by sodium attached with the clay. Means sodium is attached with the clay, and in water calcium magnesium present, so they are exchanged. So if in water there are more calcium and magnesium, so we can say it is a shallow groundwater. If there is more sodium ions, so that water means that water is ion exchange water, and many times that water is deeper groundwater. So accordingly, we can classify water, categorize water. We can also plot a particular parameter with time wise or for site wise. So upper graph shows that how the water quality varies season to season, because when the rainfall takes place, so the dilution of water takes place. The water is recharged into groundwater, and whatever parameters were exceeding in concentration, so they are diluted. Likewise, in the rivers also, when there is very low flow in the rivers in the summer season, so you might have seen that many pollutants are visible in the river. The color of the water is also kind of dirty, but when the rainfall takes place, so the water is, because the rainfall is very clear, it don't have any kind of metals, ions in the rainwater, so the water is diluted and the quality changes with seasonally. So likewise, you can also plan that at different sites what is the variation of any parameter. So at which side, likewise in the bottom figure, you can see the electrical conductivity for Jhala hand pump, it is increasing, while for other site it is low. So these kind of plots you can also plot for visual picturization of the water quality. Then next is the enhancing of water availability through water harvesting. So how we can increase the water availability, because of the climate change, water availability is going to be severely impacted. So how to cope with the climate change? We have to increase the water availability through water harvesting. So there are basically two conditions. One is the soil water conservation and groundwater recharge for hilly areas, and another is water harvesting for supplemental irrigation for plain areas. So soil water conservation in hilly areas, so you can see the main principle is the reducing we have to reduce the velocity of flow of water. When we reduce the flow of flow velocity, then the water will flow slowly, and it will recharge into the groundwater, and also the erosion will be minimized. So soil and water conservation measures for both these purposes help in conserving the soil moisture and also benefit the farmers in crop cultivation, because the moisture the period is enhanced with moisture. So the post monsoon cultivation can be done even in there is no rainfall, means in rainfed areas particularly. So these measures should be based on the slope conditions. What is the slope? Means 7 to 30% of the slope. These kind of measures can be practiced. Then managing slopes and contours for soil water conservation measures along hill slopes. So basically, there are two types of measures. One is the mechanical measures, and another one is the agrobiological measures. So mechanical measures includes all techniques of earth moving. Means we have to manage these techniques by the uh, earth or soil only. So such as digging drains, building banks, and leveling up sloping lands, contouring, terracing, and waterways. And control structures other than mechanical measures are classified as agrobiological measures. For example, crop and vegetation management, crop rotation, crop cover, strip cropping, mulching, etc. So these are the various mechanical measures. So up to 25% slope we can go for contouring or construction of trenches. And then there are terraces. So there are diversion terraces, they intercept runoff, so they can be done up to 7 to 14% earth slope. Then retention terraces, they recharge water on the permeable soils, so up to 4 point less than 4.5% slope they work. Then bench terraces is used for cultivation in the slope range of 7 to 30%. Ditches can be used along hillsides and along roadsides. And waterways convey they can be used to convey surface runoff water from contouring, terracing to a suitable outlet designed for peak runoff rates with 10 years return period, and they can be ballasted on moderate slope or prefabricated on steep slopes to avoid erosion. Then there are control and agronomical measures, means crop and vegetation management, protective plant cover to control soil erosion, means we can control erosion by protective growing up plants. Then crop rotations like legumes, grasses provide nitrogen fixation and enhance soil fertility. So that if the more vegetation is developed, so it will whenever the rainfall take place, so the velocity will be reduced by the vegetation itself, and more water will the recharge will take place. Then cover crops like legumes, perennial crops. Then strip cropping is plantation along contours. Up to 15% slope it can be used. Then mulching it is basically cover soil with crop grass residue like straw, maize, stalk, leaves, stems, so that the moisture is protected. Then there are scope for water conservation and groundwater recharge in plain areas. So first we need to identify the suitability of water conservation site. Then rainwater harvesting based artificial recharge schemes can be developed in areas where surface water can be captured, because not everywhere we can do rainwater harvesting, because if there is some natural slope, only the water can be captured. Only in that area we can go for rainwater harvesting. Then normally one first or second order drainage channel is preferred for capturing surface water runoff and for groundwater recharge, because we go for higher order than because of more flood the structure may be damaged or the capacity will be more, so more inundation will take place. So normally this kind of structure are preferred on first, and second is small streams. Open recharge wells, percolation tank, trench, pits, etc. could be constructed depending upon local conditions to enhance the groundwater availability for use in summer season. Type of any particular recharge structure shall be finalized about proper data analysis and investigations. So these are some Nala vents and percolation tanks. I have already shared these slides, so you can get this information. So where we should construct the Nala vent, what should be the site selection criteria for percolation tanks, so at which slope level, so all these, and which kind of formations these can be used. So it is all given there. Then site selection for farm pond. So in these farm ponds are suitable in relatively flatter terrain with good soil cover. And drainage area above pond should be large enough to fill pond in 2-3 spells of good rainfall. So if there are 2-3 good spell of rainfall, so it should be filled. So pond should be located where it could serve as a major purpose, because there should be a purpose why we are creating farm pond. So there should be some user like irrigation or any other thing. The junction of two drainage channels or large natural depressions should be preferred. Land surface should not have excess seepage losses, because one side we are storing water in the farm pond, and another side if it is goes in seepage losses, so it may not serve purpose. So it should be seepage free. Then criteria for dug wells, it can be where land use is cropland or fallow land or wasteland. Slope categories in between 0 to 3%, where minor lineaments are present. So dug wells can be created for recharging as well as extracting water. So when you prepare this kind of various where in various structures, so you can also project all those structures in the form of a special feature in the form of map. So where are the check dams, where are the trenches, where are the percolation tanks, so all you can have in the form of a map. You can develop this kind of map in the GIS environment. Then there are IMSD guidelines that if you I want to develop a farm pond or check dam or dike or percolation tank, what should be the condition? So these are the conditions given here. What should be the ground slope? If the ground slope is in between 0 to 5%, soil permeability is low, surface runoff is medium to high, stream order is 1, so then it is a suitable site for farm pond. Likewise, other if the slope is in less than 15%, soil permeability is low, medium to high, stream order is 1 to 4 per 1 to in between 1 to 4, then we can go for check dam. So these are the some of guidelines you can go for selection, that which type of structure should be designed in a particular area or under particular conditions. Then these are some examples. You can see bunding, terracing, contour trenching, and border strips. They also harvest water in the hilly areas and also recharge water, and also can be used for irrigation purpose. Then along contouring, the contour bands they are created along the contours can be made of stones or soil. Height could be from 1 feet to 1 meter. Length could be 10 meter to few hundred meters. Contour bands can be used for yearly field crops as well as planting trees. So these are some of the direct rainwater direct surface runoff methods. Rooftop collection also, dugout ponds, takas, khadins, diversion channels. So in different areas, there are different kind of structures also known with different names also. So this is a very common technique we use for rainwater harvesting. We collect water from a rooftop and store either at the in the in a tank kept on surface or underground. So rainwater harvesting are we can very common structure for rooftop harvesting. Then this kind of structure are available by the name takas in Rajasthan. So because there are very high temperatures, so a lot of water will go in evaporation. So they create the underground tanks for storing water. So you can see this is the Andhra Taka in Bikaner district. So they have covered for, and from roof they have connection. This is a tank, underground tank, and from roof they connect water, and also they have created some concrete platform around. So whatever rainfall takes place in this area also, that is stored, and also from roof collection they store water and use it in the summer season. And also they connect the pipe water to store the water. So this is another kind of structure they sometimes use for the irrigation purpose. So it is a concrete structure, store water, and used for growing vegetables and less water intensive crop during the summer season. So this is a Khadin kind of system. So you can see from the slopes water, they have created a Khadin bund, and the water is stored. And when the water is stored, it also recharges to groundwater. And if there is some downstream area, so there the in the right side you can see a shallow dug well. So when the water is recharged, and so downstream area they get water in the dug wells. And when this water is lost in the summer season, so using that moisture, sometimes they also used for cropping this area. So this is and the structure of Rajasthan Johar. So it is also used for water harvesting, and for various uses, for domestic use or for cattle use, like that. So there are stream flow or surface harvesting, nala bunding, gully erosion, water harvesting dams, stop dams, water diversion, percolation tanks, nadi. So these are another kind of water harvesting structure from surface runoff. So you can see like a check dam, very common name. It is used for groundwater recharge and also for storing water to for use in the summer season. And these are the percolation tanks. So percolation means these tanks are used for the recharging to groundwater. Like percolation means seepage, means water is seeping into the ground. So these are not for harvesting or surface water or for any other use. These are this kind of percolation tanks are used for the recharging, store water, rainwater harvesting in a tank, and then recharging to groundwater to increase the groundwater levels. So purpose should be clear whether we need to. You can see this is a water harvesting structure for usage during the summer season, but this structure is not for water use. You can use this water during where up to whenever the water is available, but the main purpose of this percolation tank is to recharge to groundwater. Then these are the dugout ponds. So these are also important structure in sometimes in the hilly or in plain areas. So as the name implies, dug ponds are created by removing soil and allowing water to fill in the dugout area. Most of the water supply comes from groundwater, seepage, and irrigation return. When we irrigate water, then groundwater table rises, and that the water in the downstream area comes in the form of irrigation return flow or from natural springs. So generally a site which already has a depression is chosen, and this kind of structure is created. There are advantages in areas with high evaporation losses or water scarce water supply. So these are some deeper structures. So more or less if most of the water, around 1 meter water is goes in the up to the summer season, goes in the evaporation. So if you are creating a shallow structure of 1 meter depth, so by end of summer season it will completely dry, because we have to also create a cushion for evaporation also. So these are the some 4 5 slides are left, so I will be finishing within a 5 minutes. So these are some water harvesting structures. Different states, different type of structures are used. Like in Madhya Pradesh, agroclimatic zone. Which kind of agroclimatic zone is central, semi-arid, and type of structure. So depending upon the agroclimatic zones, also some type of structures, state-wise structures, district-wise structures are present. So these slides have already shared, so you can see that for Gujarat, Chhattisgarh, which kind of. So some of the structures are common in all the states, and some structure depend upon the whether the area is plain, hill, it is hilly. So or which what are the evaporation rates in those areas. So accordingly the structures are selected for Maharashtra, Telangana, Andhra Pradesh, water harvesting for Rajasthan, Odisha, for Jharkhand. And then these are the guidelines set by the Central Groundwater Board. So you can see that topographical slope. So the first column shows the slope range, then the hydrologic group, and last column shows the aquifer condition, where the aquifer is confined or unconfined. So yeah, and again under the soil group there are three categories: consolidated formations, semi-consolidated formations, and unconsolidated formations. So if the consolidation form, these are adequate or limited according to semi, and the rainfall also it is sufficient or limited, or unconsolidated formations accordingly which kind of structure we should select, so we can also follow these guidelines. So if the steep slope is the slope is steep 10% to 20%, then we can, depending upon the formations and aquifer characteristics, we can go for particular recharge or water harvesting structure. If the slope is moderate, then there are second column, you can see different type of structures. Then further, if slope is moderate 2 to 5%, then number of structures are shown here. Then if you very gentle slope, then the bottom row you can see then the different kind of structures are available. So following these guidelines, you can also select that how which type of structure we have to select for water conservation or groundwater recharge for enhancing the water availability. Then this spring shed is also a very important area in the hilly areas. So springs are primarily source of water for the local households in the hilly regions. Spring is a natural opening in the ground where water outflows from the aquifer to ground surface. And spring set is the area of land. Means it is a spring, but what is the spring set? Spring is the area like a water set. Watershed means how much water the water rainfall falls in an area, then how much water contributes to a common single point or a river point. So likewise, the spring receives area from rainfall from how much area. So that is the spring set. So it is the area of land that contributes groundwater to a spring. And spring set management is very important in enhancing the natural flow of spring, because in present time many of the springs their flow is reducing. So soil and water conservation structures shall be strengthened in the spring shed area by demarcating the spring shed and for enhancing the spring discharge. So these are the some of the conclusions. So mostly these are the conclusions I have already summarized. So this is the availability of freshwater resources rapidly falling across the world. India will be placed as at a disadvantageous position if we fail to manage our water sources properly. So integrated water resource management at a basin scale is needed instead of currently following state-wise management practices for long-term sustainability. Then maintaining the quality of water is another critical area. Currently, 70% of water resources are contaminated. If we fail to act timely in this regard, our future water security will be severely impacted. Apart from traditional water resources, the proper conservation and maintenance, we need to look into the development of new sources simultaneously. This can include appropriate recycling of grey water, artificial recharge to aquifers, desalination of seawater by taking advantage of our long coastal line. Imparting futuristic technology, especially in agriculture, is inevitable to improve water and land productivity. In future, we have to produce more crops consuming limited water and land resources, high yield and low water intensive crops, efficient agronomic practices and intelligent irrigation methods need to be developed and implemented. If we can synchronize different departments and integrate and undertake a integrated planning, then it could also be very useful. Apart from traditional available sources, we need to emphasize on developing new sustainable sources to meet our water demands. artificial discharge of groundwater sources is another strategy to maximize the utility of surface flow. There is enormous scope in improving irrigation and water use efficiency in agriculture sector for enhancing the water availability. There is also a strong need of implementing water conservation measures, as already told. Water surplus areas can be promoted for taking up more water-intensive crops, uh, and water scarce areas can be encouraged for less water-intensive crops. Since spring is a long-term water supply source in hilly areas, their protection and sustainability is supreme. In higher altitudes, wherever available, the spring set treatment and management shall be done by involving the local communities for enhancing and sustenance of spring flows. So this is all about my presentation. So thank you very much for listening and patience. Thank you. If you have any questions, you can ask.
Hello, good evening,
Kalyani
sir.
ma'am, you can ask question.
Yes, yes. Thank you, madam. Sir, I just wanted to ask that are there any standard instruments used to check the water quality so that we can check the water quality?
Yeah, there are a number of equipments and also portable equipments and also handheld equipment to some parameter like pH, EC. So the very uh, uh, cheap equipment like 5, 10, 10,000 you can get for measurement like pH, EC, and also some sensor. And if you some parameters are to be measured at the field itself, because if you go in the field area, if you want to measure the water quality in the field itself, so some parameters you can measure like pH, EC, temperature, DO. So these are some portable sensors. And some ions you need to go for laboratory testing. Then there are also some parameters I not explained, like bacteriological parameters. So those you have to test within 6 to 12 hours. So there are number of equipments. If you need, I can provide a list of equipment. We have a very good water quality laboratory here. So there are a number of equipment like IC, chromatograph, GCMS, ICPMS. So number of equipment, and there are some automated instrument. Just you collect sample and just add samples, and so we have here number of machines. So they are running 24 hours and hundreds of samples are tested. So as such for equipments, there are not standards, but equipments are available. So if you need any help for any specifications or name of equipments, or for testing which parameters we need, which kind of equipment, so that information or list we can provide.
Okay, okay. Thank you very much, sir. I'll take your email ID from the organizer, and definitely
Yeah.
I'll email you if I need.
Yeah, in future, if you get opportunity to visit our institute, or if you anytime you are in this area, so you can visit our institute, and we can take you to laboratories and institute visits. So much of information you can get. We are also organizing, as I told, while inauguration a international conference in the month of March. So if you participate in that time also you can visit. And sometimes we also organize a number of trainings. We are also organizing physically, and many of trainings we are also organizing free of cost. You only have to come to Roorkee, then boarding, lodging, all those are borne by NIH fund. So you have to spend expenses only on travel. So number of training calendar also available on the NIH website. So many times we organize training in online mode and also in offline mode. So anybody interested, they can come and participate.
Definitely, sir. Thank you very
Yes.
much.
Thank you, madam.
Okay, any other question from the participants? Miss Jyoti, are you having any question? You can ask. I see the one hand raised, participant Jyoti.
Jyoti madam, you are not audible. If you're asking anything, you can ask.
Okay, Tsorge ma'am, if you want to ask the question, you can ask.
Maybe, am I audible?
Yes, ma'am, you are audible.
Sir, first of all, I would like to thank you for the rigorous study, what you have done for the presentation and the way you have presented the data. I wanted to ask one question that the data what you have presented for the quality, water quality, is
Yeah.
it published anywhere? From where can we get that data? If at all we want to do some research
Yeah.
on it.
Yeah. In some of the publications, data might be available, but if you need, you can send a mail request to us. So if we have that data, we can definitely provide us, because whatever data we have shown, that is available with me in my from my studies. So if you need, we can provide. But normally in publications, the authors generally do not provide because of the space requirement, and also they want to keep they may not be interested in publishing the data in public domain. So normally in some publication, you may see that only ranges are given, minimum, maximum, or average values. But if you need this data, definitely we can provide without any issue.
Yeah, as you said earlier, there are various methods to check the water quality. Our student and we are also working on one project where we are thinking of making a microwave sensor for testing the water quality. Is it feasible, and is it one of the method which you are also using?
Microwave sensor, maybe it is used in the equipments, but normally this kind of equipment directly go in the field itself and measure. Normally we are not using this kind of equipment. Only some sensor based we are including, that the portable equipment just collect water, insert that sensor in the water, and digital display is there. But some microwave, this kind of techniques, laser techniques, and atomic absorption kind of techniques, they are used in the equipment like GCMS, ICP-MS, OES, like that.
Yeah, yeah, correct. Oh, so as you said that there is a conference in the month of March. So
Yeah.
what is the detail of that conference? If you share it with the organizers, we'll be able to
Yeah, it is
come.
available on the NIH website. Just
Okay.
go for the NIH website, or if you will search in Google IGWC, International Groundwater Conference. So it will be available on the website.
Okay, sir. Thank you
Yeah.
very much for your
Welcome.
answers, and thank you for your presentation as well. Thank you, sir. Good evening.
Welcome.
All the participants, please note that feedback link is shared in the chat box. Fill the feedback link of the session 5, day 3. Is there any question from the other participants? If there are no further questions, I would...
Jyoti ma'am, you're not audible if you're asking any question.
Okay, she is not unmuting the mic also, so maybe the hand is raised by the mistake. Thank you, sir, for the insight on the effective water management and harvesting technique. So we will proceed to the end of the session. So on the behalf of Bharati Vidyapeeth's College of Engineering for Women, Pune, I extend my heartfelt gratitude to our esteemed speaker, Dr. Surjit Singh, for delivering such a thoughtful and provoking and enriching session. Your expertise and insights have been truly valuable to all of us, sir. I also thank all the participants for their patience, active engagement, and enthusiasm throughout the session. Now the expert for the next session are available in the meeting. I'll request all the participant to stay in the meeting. We would be continuing with the next session.